3 automated interplanetary stations have been producing and accumulating a certain amount of carbon dioxide over a long period, a volume sufficient to recreate an atmosphere similar to one that might have once existed on the dead planet. These installations followed their meticulously calibrated routes, heading straight to Mars with such precision that it could only be compared to the accuracy of Swiss watches equipped with atomic mechanisms. It would seem that such precision overshadows any possible random deviations. Contrary to what one might expect from such a flight, the question arises: why now, at this very moment, does this interstellar apparatus arrive at the red planet? Moreover, why did its navigator, moving with astounding precision, find itself in Mars orbit shortly after NASA made a sensational announcement about discoveries that could potentially indicate the presence of ancient life in Martian rock formations? Such a coincidence seems absolutely incredible and statistically inexplicable within the framework of ordinary probabilistic calculations. Note: the path this apparatus takes brings it as close as 30 million kilometers to Mars, and yet it remains hidden from Earth's telescopes due to being obscured by the bright light of the Sun. Tonight, we have a chance to unravel what lies behind this mysterious correlation of events, which simultaneously causes quiet wonder in some and reluctance to speak aloud in others, supporters of conspiracy theories and theorists. This is not just a coincidence. In the vast universe, where chaos and unpredictability reign, no such precision should exist. And yet, something is happening that seems to shatter all our notions and established views on how space operates. Something is happening that causes astronomers and scientists studying space to whisper or gossip quietly behind closed doors. Meanwhile, proponents of the boldest conspiracy theories begin to shout loudly, claiming that we are delving deeper into the depths of secret knowledge. However, we cannot dismiss everything as coincidence. There is a deeper meaning to everything happening now, and it directly points to something much more significant and possibly even terrifying being associated with this situation. In the vast universe, governed by what seems like chaos and randomness, no such precise coincidences should arise, like this one. In the orbital space interacting with Mars, something is occurring that could completely overturn our most fundamental understandings of how the cosmos is structured and functions. And all this is evidence that at the heart of what is happening, there is something special, and very soon we will find out what this phenomenon is. Stay with us, because what Atlas is actually doing near Mars may turn out to be one of the most terrifying discoveries humanity has ever made in its history. We begin to tell the first part of our story, and it says that there is life on Mars. For more than 4 years, the Perseverance rover, launched by NASA, has been quietly and without fuss studying ancient clay rocks in the Jezero Crater area. It continuously collects data, searching for signs of past conditions capable of supporting life. And then, in July 2024, something unusual happened. Structures were found in the Martian soil that scientists first called leopard spot textures. These patterns were discovered in a sample obtained by the rover near the so-called Chayava Falls, close to an outcrop known as Bright Angel. And these patterns are not merely beautiful or curious markings in the stone. They represent one of the strongest and most promising signals that may indicate the presence of life in the planet's past, potential biosignatures. Designated as Triatlas, astronomers made an important clarification. It became the third confirmed interstellar visitor recorded in the history of human observational science. This remarkable entity was named Atlas. Within the framework of modern asteroid early warning systems, which could pose a threat to Earth, there is a network of high-tech telescopes located in Hawaii, Chile, and South Africa. These instruments are primarily intended for searching for potentially dangerous celestial bodies that may approach our planet. And although their main task is to detect objects capable of causing catastrophic consequences, sometimes during observations they encounter something much more mysterious and unusual. This triatlas moves along a hyperbolic trajectory. Astronomers refer to this type of movement as a hyperbolic orbit. And this term is not accidental. It indicates that the object is moving along a path clearly showing that it comes from beyond our solar system. Unlike planets and comets, formed in the interplanetary space within our system, this object does not revolve in an elliptical orbit associated with the Sun. It essentially moves one way, not returning, as if falling to us from the celestial expanses to pass nearby or, rather, fly by. The significance of this discovery is particularly important. Its orbital eccentricity exceeds 1, which means that the speed of the triatlas is so great that it can leave the gravitational field of our star forever, going into interstellar space. What is also remarkable, and this is what makes the heartbeat faster, is that simultaneously with the announcement of the discovery made by space agencies, an object is found on Mars that appears to be one of the strongest candidates for biosignatures, signs of life. And here the intrigue intensifies. While Earthlings were dealing with the potential language of the mysterious interstellar traveler, Atlas was already racing towards its inevitable fate, a collision with the red planet. Time seems to be deliberately following its own script, coincidentally aligning with this cosmic spectacle, as if fate itself is hinting that something important, something fateful for our research, is happening at this moment. The minimal set of data about the triatlas creates a plot reminiscent of a science fiction detective story on a cosmic theme. The entire picture is confirmed. This is an object of natural origin, without traces of artificial structures, radio signals, or complex maneuvers that could be perceived as signs of intelligent activity. And yet, the chemical composition of this guest from interstellar space tells a different story. Spectroscopic observations conducted with the James Webb Space Telescope and equipped with the Schwarex instrument revealed a rare and unique combination of substances. The comet currently being observed contains a dominant layer of carbon dioxide, with a ratio to water approaching 1. In most cases, comets are considered dirty snowballs, rich in icy water and various impurities. But here arises a surprising difference. The Atlas clearly ejects carbon dioxide into space, not just water. Rumors quickly spread in the astronomical community that in September, a strange green glow was seen emanating from the comet. This phenomenon, according to scientists' assumptions, could be related to the release of substances from the core, such as dicarbonates or cyanide compounds. And although these chemical compounds are not considered exotic or special, their presence in an object originating from another star system arouses considerable interest. They prompt questions about how and where this mysterious interstellar guest could have formed, and why its chemical composition differs from familiar earthly and interplanetary samples. As expected, various theories began to emerge and multiply on the internet. Perhaps it is the comet, rich in greenhouse gases, particularly carbon dioxide, that played a key role in the historical revival of Mars. Theoretically, such a concentration of gases could significantly enhance the created atmosphere of the red planet, making it denser and capable of retaining solar heat. This, in turn, could initiate a long process of restoring conditions for life, starting with a proposal based on conjectures and cosmic coincidences. However, like many other hypotheses, such ideas are merely guesses wrapped in cosmic coincidence. Yet, as we will see later, the universe sometimes presents us with such compelling and astonishing patterns that completely ignoring them becomes practically unacceptable from a scientific standpoint. It is quite possible that certain mysterious events or objects accelerating our understanding are connected with what is currently happening with the third named object, 3I Atlas, on Mars' orbit. This issue is not just idle curiosity. It will lead us through a tangled labyrinth of astronomical research, ancient mysteries, and possibly indicate that we are witnessing something far more significant than a mere coincidence in space. We are presented with a perspective that requires us to fasten our seatbelts and prepare for a journey that begins with chemistry and then smoothly transitions into discussions capable of overturning our understanding of life, intelligence, and our place in the universe. This is the second part of our journey, and it is called Anomaly. To understand why the object 3I Atlas deserves such attention and why it is considered so unusual, it is important to understand what makes its orbit hyperbolic. Briefly, compare it to the situation when you throw a ball straight up. It moves along an arc due to inertia, slows down, stops at the peak, and then falls back down. But if you throw the ball so hard that it never returns, completely escaping Earth's gravity, that is analogous to a hyperbolic orbit in space. In astronomy, eccentricity is a measure that indicates how much an object's orbit deviates from a perfect circle. For simple, perfectly circular orbits, this measure is 0, for slightly elongated ones, about 0.17. But when the eccentricity exceeds 1, it indicates an escape trajectory that takes the object beyond the gravitational pull of a planet or star forever. Therefore, when we talk about 3I Atlas, its eccentricity significantly exceeds 1, which convincingly indicates its interstellar origin. This makes it only the third such object confirmed by scientists as an interstellar visitor, joining the mysterious Oumuamua comet discovered in 2017, and the more traditional Borisov comet registered in 2019. But the most interesting part begins here. Oumuamua exhibited signs of unusual acceleration that could not be explained by standard models of physics and gravitational mechanics. Its trajectory changed within tactical limits, sparking hypotheses about its artificial origin. Unlike it, Borisov behaved as expected from a typical comet, with a typical gas and dust envelope, and its emissions seemed predictable and understandable. So where is 3I Atlas now? It seems to balance between these two extremes. This very feature makes the object such an enticing mystery. It is clearly of natural origin, lacking geometric shapes, radio transmissions, or unusual physical properties that contradict our knowledge. In preparation for more detailed study, the James Webb Space Telescope, the most advanced tool for observing space, began closely monitoring 3I Atlas from the moment of its discovery. And what it found once again contradicts our initial expectations. Ultimately, we are faced with a mysterious layer of gas and dust surrounding the comet's nucleus, which turned out to be different from what was previously imagined. It is primarily not water vapor, but gaseous carbon dioxide. This fact greatly surprised scientists because initial assumptions and expectations suggested that water vapor would dominate the comet's tail and the sphere surrounding the nucleus. The ratio of CO2 to potassium oxide in this substance is approximately 8:1, one of the highest ratios for any comet in the history of observations. To understand why this is so, it is worth recalling that most comets resemble cosmic snowflakes upon closer inspection. Their surfaces consist of ice and dust, and as they approach the Sun, these icy surfaces begin to sublimate, turning into gas, and creating a characteristic tail of water vapor, dust, and trace gases. But with this comet, everything is different. The model that has long described the behavior of dirty snowball comets does not fit in this case. Observations show that the release of carbon dioxide occurs as easily as the evaporation of dry ice, specifically frozen carbon dioxide, which quickly turns into gas with moderate heating. This unusual chemical picture provides food for thought and opens up several interesting hypotheses for scientists. Perhaps this object formed in its original star system in the so-called zone where the temperature was such that carbon dioxide had already frozen, while water remained in a gaseous state. In other words, its original composition was likely determined by the temperature conditions in the part of the protoplanetary system from which it formed. There is also a hypothesis that the comet's surface may have been subjected to prolonged exposure to cosmic radiation over millions of years while in interstellar space, leading to the formation of a carbon-rich layer. Such a layer, when heated as it approaches the Sun, is likely to release carbon dioxide. Another interesting scenario is the theory of so-called selective sublimation. If the nucleus is covered with a layer of ice saturated with carbon dioxide, it may suppress the release of water ice from deeper layers, shifting the observed ratios toward the predominance of carbon dioxide. As the comet continues its approach to the Sun, we can observe a dynamic change in this ratio, which will help in uncovering its icy history. Its book, written in layered strata. As its core warms, different layers begin to emerge, each holding important clues about early conditions within the protoplanetary system. Recent studies have discovered and recorded the appearance of additional compounds, such as carbon monoxide, carbonyl sulfide, and water hidden beneath the carbon dioxide-rich cover. Each of these discoveries contributes to the complex mosaic of this mysterious cosmic visitor's origin, expanding our understanding of its chemical composition and formation history. The Spectrum Space Telescope, with its high-precision infrared spectrometers, has independently confirmed these measurements, significantly increasing confidence in the results obtained. This is evidence that the chemistry observed on the comet is quite unusual and would often seem impossible for an object formed within conventional concepts. Moreover, in September, when ground observers noticed the comet acquiring a bright, emerald glow, a plausible theory arose. Such hues are most often associated with the presence of dicarbon molecules, that is, bonded carbon atoms, or cyanide compounds. Although these molecules are not considered truly exotic and are often found in interstellar nebulae, their sudden abundance in the comet's composition raises many questions among scientists. Especially in light of the fact that in the homogeneity of interstellar objects, they are present in significant quantities. However, one detail continues to unsettle astronomers and cause considerable confusion in their established views. It is the limitation of measurement capabilities, which by its nature imposes significant constraints and often hinders obtaining a complete and accurate picture of what is happening. Previously used spectroscopic research methods were heavily dependent on numerous factors. Their indicators could be interfered with by such disturbances as dust, various atmospheric interferences, as well as the rapidly changing position and distance of the studied objects relative to the Earth and the Sun. All this complicated obtaining clean and accurate spectra, as our planet's atmosphere could distort the signal or create background noise. Moreover, the chemical composition of comets and other celestial bodies can change significantly at different stages of their approach to heat sources. For example, when solar heat is gradually absorbed and penetrates into the inner layers of their core. Such changes can reveal information about a composition that was not initially anticipated and uncover entirely new, unexpected components as research missions progress. As a result, we strive to analyze the chemical set moving through space at speeds reaching 30 kilometers per second, covering millions of kilometers through the rarefied dark void, observed through a powerful telescope. The very fact that we managed to capture any significant information at all is a remarkable achievement. However, realizing that the data we have uncovered may challenge existing notions about the chemical composition of interstellar space and the processes occurring within it is both alarming and suggests we are on the brink of new discoveries. This becomes especially relevant as the spacecraft, named Tri-Atlas, races towards its long-awaited encounter with Mars, and these chemical anomalies take on special significance. In this context, carbon dioxide is not merely an unusual component of a comet or telescopic imaging. It is the main constituent of Mars' atmosphere, the primary greenhouse gas, which once created conditions on the red planet capable of supporting life. This gas once formed a dense and potentially habitable atmosphere, making it a crucial key to understanding the history of the red planet. If someone were to attempt to return Mars to a habitable state, carbon dioxide would logically be the most effective mechanism for delivering the necessary elements. Yet, despite all the general assumptions, we are only taking the first steps in understanding this complex and mysterious chemistry, while simultaneously encountering temporal coincidences and unique circumstances that, although they seem unusual, remain within the realm of possibility. All this unfolds against the backdrop of a trajectory bringing this cosmic chemical box within just 30 million kilometers of Mars, approximately 23,000 astronomical units, in just a few weeks, making this moment unique. The main question that arises with each observation, each spectral measurement, or meticulous calibration of instruments is, why are these chemical anomalies manifesting now, especially in such quantity and with such clarity? Why does this particular chemistry appear in this region of space? And why is all this connected to Mars? These questions haunt the minds of scientists, driving them to seek answers in the depths of cosmic patterns and causal relationships. Part 3 is special, important, and very symbolic. The time of proximity to our red neighbor is the October flyby point. It is important to mark in calendars, October 23, 2025. That is when Tri-Atlas will make its flyby past Mars, leaving a distance ranging between 28 and 30 million kilometers, or, to be precise, between 1.9 and 2 astronomical units. To better imagine the size and scale, it is worth saying that this is approximately 75 times. Undoubtedly, we cannot remain completely indifferent to the upcoming cosmic event, which promises to be very important for our science. The European Space Agency has confirmed that orbiters directed towards Mars are preparing to conduct observations during its flyby, scheduled for the October period. Among them, two missions stand out: the Mars Express satellite, launched back in 2003, and the Trace gas orbiter, put into orbit in 2016, specializing in studying the chemical composition of Mars' atmosphere. These space probes will provide scientists with a unique opportunity to obtain invaluable data about Mars from a very close distance right during its flyby past the red planet, as well as when passing through the safety zone or strong streams of cosmic dust. The most promising and exciting is the chance to observe this cosmic object using these hardware means, which will open up wide opportunities for researchers to discover new facts. For example, with the help of high-resolution cameras, it will be possible to take images showing the smallest details of comet nuclei or structural elements of their structure, invisible to our eyes from the Earth's surface. Also, the ultraviolet and infrared spectrometers of these satellites will be able to detect specific spectral lines characteristic of substances such as cyanides, carbon monoxide, and other compounds present in the tails and comets. And the dust analyzers installed on board these devices are even capable of capturing particles erupting from comet tails, giving scientists the opportunity to obtain samples of interstellar matter in close proximity. All this represents a unique scientific precedent and indicates that the stakes in this mission are extremely high. Meanwhile, one of the key goals is to obtain the third set of data on the 3I Atlas system, which helps scientists understand the composition of interstellar substances and their formation processes. Such analysis will undoubtedly become one of the few ways to compare the chemical composition of substances formed in other star systems with those characteristic of our solar system. The high content of carbon dioxide found in the composition of this cosmic object may provide important insight into processes related to planet formation and atmospheric development in various corners of the universe. And perhaps it will help us understand how the atmosphere in our solar system, which in the distant past could have been denser and more Earth-like, came to be. Another equally important aspect of this situation cannot be overlooked. Recently, Mars has been the focus of special scientific attention, as potential signs of biomarkers have been detected in Jezero Crater, a site where significant geological processes occurred earlier in its historical sequence. The thin atmosphere of this planet, consisting of about 95% carbon dioxide, is merely a remnant of what was once much denser and closer in composition to Earth's. It is likely that billions of years ago, Mars had conditions that allowed for liquid water, lakes and rivers that carved its Jezero Crater and many other formations across its surface. What if these current observations are not a mere coincidence but indicate that the carbon dioxide-rich chemistry observed in the 3I Atlas system is essentially part of a long-term process by which Mars is restoring its atmosphere after catastrophic events? Of course, it is important to maintain skepticism and objectivity, as one comet, even with its unusual chemical composition and richness in volatiles, is unlikely to have a significant impact. The amount of gas it contains is roughly equivalent to a glass of water poured into a vast pool, and this cannot drastically change the atmosphere of a planet like Mars. For billions of years, it has been losing its atmosphere to space, blown away by the solar wind, because it lacks a strong magnetic field that could protect it. Undoubtedly, the geometry and celestial mechanics continue to amaze with their facets and complexity, evoking genuine admiration from those who delve into the mysteries of the cosmos. Particularly impressive are the instances when an interstellar visitor, precisely the object carrying atmospheric components most relevant to Mars's conditions, appears just as we obtain the most important and compelling evidence of ancient Martian life. This extraterrestrial traveler, like a messenger from the depths of space, approaches our path at the same time scientists begin to categorically assert that life once thrived on this planet millions of years ago. Interestingly, the comet moving toward the red planet will be hidden from our earthly observations precisely when it enters the collision zone with Mars. This creates a sort of cosmic privacy window, a unique time frame when it disappears from the view of Earth-based telescopes, leaving us in complete silence and anticipation. If all this were a script devised by filmmakers, many directors would consider it too coincidental to believe in its plausibility. However, nature loves its mysteries and surprising coincidences, and it is in such moments that we can understand that our world is much richer and more complex than it appears on the surface. Earthly observations will resume once the celestial telescope, Atlas, emerges from the shadow of the Sun, which will happen at the end of November or early December. Only then will we be able to see in more detail the changes that have occurred with the comet. After passing perihelion, the closest point to the Sun in its trajectory, its external appearance will radically change. We will see an object that, having passed through extreme conditions, has shed its layers and revealed its hidden secrets to the world, locked within its core, frozen in time and space as if in eternal frost. This process of destroying the outer layers and exposing the core is key to understanding the nature of such bodies and their role in the history of our universe. The European Space Agency has been as candid as possible about the upcoming challenges in observing this object, honestly warning of possible complications and limitations. A distinctive feature of the current interstellar visitor is its extraordinarily complex route and timing. The trajectory and time of arrival are such that developing a minimally risky and effective mission for interception becomes practically impossible. This is due to high speeds, vast distances, and our current technological limitations. We can only observe this object remotely, using spectroscopic analyses, photometric data, and all available means provided by ground-based and orbital instruments. All this information, collected over a short but extremely important period, usually ending in October, gives us valuable keys to understanding cosmic mysteries. Nevertheless, such observational limitations may be even more appropriate than they seem at first glance. Sometimes the deepest and most important mysteries of the universe remain beyond our perception, and they can only be observed without touching or interfering. In such moments, it becomes especially clear that questions are often more important than immediate answers. And while the Triatlas, as this interstellar object is called, swiftly races towards Mars, carrying with it its load of carbon dioxide and hidden cosmic secrets, we can only wonder, what exactly will happen during these weeks when the object hides behind the solar horizon, and what will the Martian orbital probes, sent in its direction, see? The entire story that this next cosmic wanderer will tell us, about the chemical composition of distant stars and possibly about the future of the inhabitants of planet Mars, depends on what can be recorded during its passage. The orbital mechanics of this journey are simple and clear. The object moves along a predictable trajectory that we can calculate, but the chemistry hidden within it is more complex. Explaining what is happening can be guided by a rational and logical approach, as interstellar objects arrive from various and often random directions. They appear in our solar system at the most unpredictable times because their appearance and movement are governed by the inexorable laws of celestial mechanics, which control the motion of everything in the universe. For example, a 3-comet astronomical cart, hypothetically designated as a 3 million asteroid comet structure, begins its journey from distant stellar neighborhoods millions of years ago, long before humans appeared on Earth, even before life emerged on the planet. The time of appearance of this object is usually millions of years, and the hyperbolic trajectory it follows is determined by the gravitational dynamics of its original system and the powerful gravitational influences it experienced during its solitary journey through the cosmic abyss. These trajectories, especially hyperbolic ones, do not lie, as they provide an accurate representation of its origin and the global history of its movements. When we talk about a calculable eccentricity exceeding 1, we encounter an important and fundamental aspect. It is an indicator that testifies to the deep nature and fate of the object. The 3-comet structure is an unbound object from our Sun, moving at a speed that exceeds what is necessary for orbital capture, and ultimately its path will lead it back into interstellar space, as it is not captured by the gravity of our planet or star system. It is an uncaptured visitor, a cosmic wanderer somehow aimed at our Mars, as if it was originally sent on a one-way flight, driven by physical laws that completely disregard human timeframes or planetary biology. And here the story gains particular significance. From the perspective of a narrative or hypothesis, everything that seems random is actually part of a vast chain of events, layer upon layer accumulating in the observer's consciousness until the mass of indirect evidence becomes overwhelming and obvious. Then, one might say, it is impossible to ignore the completed chain of evidence. So let's figure out what we are really dealing with in this situation. First, it is worth noting the geometric feature of the perihelion of the 3 comet structure. It is expected to reach its closest point to the Sun on the 29th or 30th of October, just inside the orbit of Mars, at a distance of approximately 1 to 2.5 astronomical units. At this moment, the comet is in the optimal zone for the strongest solar heating, which causes the activation of gas emissions and changes in its appearance. During this period, the comet approaches Mars while simultaneously moving away from our ground-based telescopes on Earth, as it undergoes another solar conjunction. At this moment, it disappears from view, hidden behind the solar disk, creating a perfect window when our observational tools are unable to track its movements. For several crucial weeks, the largest and most sensitive telescopes on the planet simply cannot record what is happening near Mars because the comet is obscured by the solar shadow. This is precisely the time when anyone wishing to engage in cosmic activities secretly would have the best cover, as visibility is completely absent. The second issue that continues to concern researchers is the chemical composition of the comet. The only surprising, yet not impossible, fact is the dominance of carbon dioxide, a gas commonly found in comets, but in this case, it seems particularly prominent. This is especially interesting since this gas is most necessary for the restoration and regeneration of Mars' atmosphere. Currently, its density is only about 0.9% of Earth's atmospheric pressure, making the Martian atmosphere terrifyingly thin. Therefore, any process capable of increasing the concentration of it moves along a trajectory determined by the fundamental laws of physics, and its path is not influenced by any artificial interventions or controlled programs. One could say that this object is a simple, immobile piece of frozen chemical matter, subject to Newton's laws. It does not deviate from its course for any mysterious or unusual reasons. Its movement is a pure manifestation of the gravitational influences it encounters in the universe. No signs of conscious control or artificial interference in its trajectory have been detected. Within the scope of observations conducted by NASA, everything corresponds to the natural processes, the nature of this object, and its behavior in the environment. There are no signals, structured signals, or hints of geometric precision or impossible maneuvers indicating that something created by intelligence is behind it. The object poses no threat to Earth. No indications of its artificial origin have been found. Then the question arises: why do we feel that this event is very important and significant? Perhaps the key to understanding lies in the fact that we are witnessing the intersection of 2 different cosmic histories. 2 narratives that our minds endlessly try to merge into one cohesive picture. The first is the story of ancient life on Mars, from the times when the red planet had a denser atmosphere and liquid water existed on its surface, allowing for the development of life. This narrative speaks of the past, a time when some form of biological activity, if not entire ecosystems, could have existed there. The second story is about the present, concerning the interstellar chemistry we are observing now in the interstellar spaces, precisely at the moment when we are contemplating the potential opportunities for the emergence and development of life on other planets, including Mars. The triatlas is not just a dataset, it is a story about our present, about how the universe itself is rich with chemistry capable of sustaining life if favorable conditions are created. But an unexpected question arises. What if all this is not a coincidence or chance? What if the preparation of the atmosphere we observe in the area called the Third Atlas is not a fantasy or the product of scientists' imagination? What if that chemical component, rich in carbon dioxide, as well as other components present on Mars, is not the result of random cosmic events or remnants left after the destruction of previous conditions, but a deliberate design, more complex than mere alien intervention? It's not necessarily about little green men controlling cosmic objects, but about the idea that such a chemical composition is not just a coincidence, but the result of natural selection operating on a universal scale. What if the universe itself is oriented towards creating conditions conducive to the emergence of interstellar objects with a chemical composition favorable for the formation of habitable planets? And what if the same processes that form an atmosphere capable of supporting life simultaneously create mechanisms for its delivery and preservation on suitable planets? This line of thought goes far beyond cold speculation. Nonetheless, it is worth noting that carbon dioxide and water, the main components we have found in the composition of the interstellar object, are also fundamental elements of the atmosphere of planets capable of supporting the life we know. Although the ratio of these elements may seem unusual and atypical, it is precisely the chemical composition that could become a benchmark for terraforming projects. Of course, all this is hypothetical and implies that it is even possible to carry out such a process on Mars, which today is considered a major challenge and a subject of debate. The red planet lacks a strong magnetic field that could protect its atmosphere from solar radiation and solar wind. Even if suddenly all the wealth of volatiles to which one could resort were delivered to the area of 3 astronomical units, the long-term mechanisms of atmospheric loss, their impact, ultimately negate all temporary successes. But what if this circumstance leads us to 2 different lines of interpretation of what is happening? The first, scientific, approach consistently regards the Tri-Atlas as a unique, unusual, but ultimately natural asteroid or comet, whose approach to Mars is a mere coincidence within astronomical probabilities. Support for this version is found in the collected data, which aligns well with the understanding of physical processes and confirms that such unusual phenomena do not require extraordinary evidence. This perspective focuses on the mechanics of space, its logic, and explanations. At the same time, there is another line of thought, more speculative, which raises a series of questions beyond traditional science. Why this particular chemical mixture? Why now, at this specific time? Why Mars, although this does not necessarily imply intelligent intervention or any design? Perhaps it is about patterns and possibilities that do not fit into conventional frameworks, which may arise from laws not necessarily related to conscious design. Both approaches share one thing, the main enigma. We are currently at a point in time where ancient Martian biology and interstellar chemistry unexpectedly collide, causing us to doubt simple explanations and prompting us to seriously consider the possible randomness or regularity of this phenomenon. If someone wanted to make Mars habitable, what would they bring there? First and foremost, it would be carbon dioxide, necessary for creating a greenhouse effect, water, without which biological processes cannot exist, and organic compounds, providing chemical complexity and diversity. Exactly the kind of symbiotic cocktail we observe in the coma of Tri-Itl. This raises a crucial question, combining the rigor of scientific approaches and the curiosity inherent in speculation. How can we distinguish truly meaningful patterns from mere coincidence in a cosmos seemingly capable of both? Part 5. First, the seed of doubt. The lack of information and gaps in our knowledge about the coma of Tri-Itl create the perfect ground for the emergence of unusual hypotheses and theories. The limited observation time, as the comet passed by Mars less than 6 months ago and later, due to solar conjunction, will become inaccessible for observation from Earth. All this significantly complicates the task of obtaining a complete picture. In such a moderate period, it is hardly possible to accurately determine the orbital parameters, let alone conduct a deep analysis of the chemical composition of an object moving at about 30 km per second in the airless space of the cosmos. In online discussions, this uncertainty manifests in various ways. Some tend towards extreme interpretations, emphasizing the possible alien origin of the object, conspiracies, or technological artifacts, while scientists and experts relentlessly emphasize the need for a balanced approach and avoid panic or unfounded conclusions. On social media, there is often a cacophony where information algorithms encourage the spread of the most vivid and provocative hypotheses, enhancing the sense of mystery and possible extraterrestrial intervention, despite the lack of evidence. In this situation, influential figures with millions of followers and public support can shape mass perception based on one or several bold posts, even if their expertise in astronomy or astrobiology remains questionable. The response of the space agency, NASA, has been a model of effective communication in crisis situations. They confirmed the fact of unusual observations, offered natural explanations that do not rule out the possible presence of natural phenomena, and emphasized that there is currently no compelling evidence of the object's artificial origin or threat to Earth. This was particularly clearly expressed by Dr. Paul Chodas from the Center for Near-Earth Object Studies, who focused the audience's attention on the need for sober assessment and avoiding hasty conclusions. All available information confirms that the object, named 3 Atlas, is essentially an ordinary comet, albeit with a striking and rare chemical composition that, despite its unusualness, does not exceed the capabilities and knowledge of modern astronomy. However, this case differs from previous instances where alarming messages about potential threats related to hypothetical technologies or secret discoverers of cosmic objects appeared online. Unlike them, the Atlas telescope network was specifically designed to ensure the fastest and most transparent publication of any information obtained during observations. Observation of this object was conducted within hours of its discovery, and all data was immediately published and accessible to scientists worldwide. Such a level of promptness and openness makes it practically impossible to successfully conceal or distort information about potentially dangerous or unusual cosmic objects, significantly limiting the possibilities for large-scale conspiracies or covert operations. If 3 Atlas were indeed exhibiting anomalous properties, such as sudden course changes, emitting structured signals, or demonstrating complex geometric shapes, such signs would have been promptly recorded and published by astronomical communities worldwide. In this case, observers could have seen evidence confirming the extraterrestrial origin or technological nature of the object. However, no such signs have been detected. The object moves in a completely predictable hyperbolic orbit, which is fully consistent with the laws of gravity and the motion of comets. Its trajectory is entirely explainable, showing no deviations or mysterious maneuvers that could indicate artificial control. Moreover, observational systems such as radio telescopes do not detect any exotic radio signals or structured transmissions indicating the presence of conscious or technological activity. The considered comet appears as a blurred and diffuse object, lacking clear contours or geometric patterns that might suggest artificial origin. Even its chemical composition, although mysterious, remains within the theoretically possible variations for comets formed in different regions of star systems. Flashes of chemical signatures that would indicate unusual technological processes or extraterrestrial sources have not been recorded. Furthermore, chemical analysis points to a composition similar to that characteristic of many natural comets formed in protoplanetary clouds at different times and under various conditions. As for the object's physical behavior, it moves along a trajectory strictly adhering to the laws of gravity and classical orbital models. Its hyperbolic trajectory is unquestionable and fully explainable from a scientific standpoint. Radio telescope observations also do not reveal any artificial signals, hints of intelligent technologies, or artificially created structures. The geometry of the object and its visual appearance do not show anything unusual. It appears blurred and indistinct even at high-resolution images, without manifestations of clear lines, patterns, or shapes that might suggest artificial nature. The chemistry of this celestial body, although mysterious, does not exceed the bounds of possible natural scenarios created in individual star systems. It demonstrates only what is typical for comets formed in diverse interstellar environments where multiple processes and interactions occur. In other words, everything we observe at the moment is a natural phenomenon, entirely typical for such objects, and none of it indicates the presence of any artificial or extraterrestrial technology. Ultimately, despite initial assumptions and concerns, all current research methods and observational capabilities confirm that the object known as 3 Atlas is merely one of the countless comets traveling along their orbits in our solar system. Undoubtedly, in life, it often happens that the absence of concrete evidence that a certain phenomenon or event has occurred or not does not mean it is absent or impossible to detect. In legal practice, for example, it is often said that absence of evidence is not evidence of absence, and this expression is quite applicable to scientific research and any field where we seek the truth. However, it is truly important to ask ourselves, are we paying enough attention to carefully consider all the signs and indications that might lead us to the right answers? And are we using all the necessary tools to look at the situation as broadly and accurately as possible, at the right moment? Recent reports of mysterious green luminescence observed in September add an additional layer of complex mysteries and uncertainties to our investigation. This is evidence that the nature or processes causing this glow remain subjects of active debate and interpretation. One hypothesis suggested that the interaction of dicarbon and cyanide might produce the emerald hue observed in comet particles. Yet, precisely which molecular processes underlie this bright and unusual shade remains in question. The science exploring these processes faces numerous challenges: different telescopes, various atmospheric conditions during observations, and the methods used to present results can lead to contradictory conclusions regarding the chemical composition and coloration of the comet. This seemingly illustrates a key dilemma familiar from the history of human knowledge. Science corrects its errors until something becomes more evident or convincing. Meanwhile, conspiracy theories, on the contrary, tend to link disparate observations into a single, often very appealing narrative that resists scrutiny and re-evaluation. This is their peculiarity. They bypass many criteria of scientific rigor, creating closed systems of interpretations that are harder to dismantle or refute. The object known as Atlas lies on the borderline between these two approaches. In laboratory studies, it demonstrates unusual chemical properties, which arouse genuine scientific interest and a desire to understand the nature of these processes. However, the claim of its possible connection to Mars is, in essence, a cosmic coincidence, nothing more. Its approach to the red planet is an astronomically typical phenomenon, and under natural conditions, it fits well within the established notions of the movements of bodies in space. The period of this approach lasts several weeks, and the situation seems not only scientific but also dramatic. Everything appears as if the object is deliberately created or so heavily contrived to mislead both those seeking a simple explanation and proponents of more unusual hypotheses. This inherent uncertainty gives rise to what we call the uncertainty effect, a psychological phenomenon where we adapt to incomplete and contradictory information, and our minds become particularly active. We start looking for patterns where there are none, and are willing to consider even the most illogical or unusual explanations. This is how our curiosity works. It drives us to new discoveries, even when the data contradict each other or remain unreliable. The Atlas object raises many questions for us. The presence of a large amount of anomalous data stirs interest, while leaving room for interpretations that fit within the framework of natural phenomena. Nevertheless, the approach to Mars, if it is indeed happening, occurs under conditions that require us to consider the limitations of our knowledge and the power of cosmic time. For several weeks, the Information Technical Device, named ITL, will operate near Mars, while telescopes on Earth, habitually pointed at the celestial space, will point meaninglessly at silent emptiness. When we re-establish contact at the end of November, the question arises: will we see the same object again, or have its transformations already altered its nature? The passage of the Sun through perihelion, the closest point. Will a third Atlas mission emerge after completing its current program and confirm our assumptions about the nature of the supposed comet, or, on the contrary, reveal new, more complex and unexpected understandings of interstellar chemistry? The most important aspect of this question is not so much what the new expedition will discover, but that the events may radically challenge our existing knowledge and hypotheses. The most troubling of these is the possibility that the third Atlas mission may likely end its flight near Mars, be subjected to intense heating during re-entry through the atmosphere, and ultimately leave the bounds of our solar system, taking its immeasurable secrets with it. In such a case, scientists will be left with only spectroscopic images, orbital path calculations, and endless speculations about what happened during those mysterious weeks of October, periods that will remain beyond the reach of direct observation. It can be said that such a development will undoubtedly be a true test for the scientific approach. Not so much in the context of determining whether the mysterious object, whether heavy or artificial, is the result of natural processes or a man-made phenomenon. The main thing is to maintain academic rigor and objectivity, while acknowledging that our knowledge of such events is often no more than shadows in a dark room. The more we learn about them, the clearer it becomes that perhaps we will never fully know everything. Ultimately, what matters most is the ability to learn, maintain a calm mind, and apply analytical reasoning when faced with extraordinary, even paradoxical, phenomena. Is it possible to hold two seemingly opposing ideas simultaneously? On one hand, the assertion that our universe is far stranger than we imagined, that unusual or mysterious events require proper and convincing evidence, and on the other, the necessity to keep an open mental flexibility and readiness to acknowledge that what is happening might change our understanding of the cosmos. This may be the main challenge, to understand that the most important question is not what exactly this mysterious object is, whether it's Tri-Atlas or something else, but what this event teaches us. Does it teach us how prepared we are to face truly anomalous phenomena, at what cost we are ready to accept these changes, and what challenges this will pose to our consciousness? Or, more broadly, it is not only about chemistry, physics, or astronomy, but also about the limits of our perception and the ability to think clearly in conditions of cosmic uncertainty. The true mystery may not lie so much in what this object is doing in orbit around Mars, something that seems alien and incomprehensible, but in what we must learn from observing it. In the end, it is not only a test of our technologies or knowledge but a way to test our ability to comprehend and adapt in conditions where the boundaries of the familiar are expanded, and predictability disappears. As for historical parallels, they can be found since humanity first looked at the sky. In those distant times, many centuries before the advent of modern telescopes and satellites, people observed celestial phenomena with both awe and fear. The Sumerians, ancient Egyptians, Maya, they created systems to track the movements of stars, planets, and lunar cycles, relying on their knowledge and traditions. However, they had no way to understand the nature of those objects that might exist beyond our system, beyond its boundaries. In their records, despite the richness of legends and myths, there was practically no information about visitors similar to what is now called interstellar bodies. And although such evidence has not been found, this lack of data only reveals our limitations in observing and understanding the real cosmos. When ancient people looked at the sky, their attention was mainly drawn to phenomena that could be predicted and explained: the movement of planets, cycles of eclipses. Ancient astronomers observed Venus with extraordinary precision and attention, recording its every movement and transformation. However, their records often mentioned other celestial phenomena, guest stars, which modern researchers interpret as supernovae or comets appearing in the sky in those distant eras. These parallels between ancient astronomy and modern discoveries represent a fascinating cultural artifact. Each historical record seems to take on new meaning in the light of contemporary knowledge. However, it is important to remain absolutely clear: as of today, we have not the slightest evidence that mythological stories and legends were directly linked to specific interstellar objects. Today's scientists and historians understand that the human tendency to seek patterns in coincidences remains as strong as it was 4,000 years ago. Nevertheless, this natural tendency sometimes leads to confusion, especially when it comes to unusual phenomena, such as 3 unusual flashes or mysterious bright objects appearing in the sky. We instinctively turn to the past, trying to find historical examples of such events, even if none exist. This behavior, driven by our ability to find patterns in chaos, served our ancestors in the process of survival. They distinguished a rustling bush hiding a predator from the wind harmlessly swaying the leaves. But when this same mindset is applied to cosmic phenomena, the tools developed for survival can have the opposite effect. They contradict reality and can lead to false conclusions, creating illusions of connections and patterns where there are none. Let's delve deeper into how, throughout history, real and imagined connections between comets and societal changes gain significance. For instance, the appearance of the famous Halley's Comet in 1066. Its bright glow was interpreted as a divine omen of the impending Norman conquest of England. Another time, in 1577, the appearance of a great comet convinced European nobility that divine intervention signaled upcoming changes, among which the Protestant Reformation stood out. It is no coincidence that Chinese astronomers of the time created complex systems to correlate the appearance of celestial objects with important events in dynasties. Their event map became a kind of star calendar of political and social shifts. However, none of these connections, whether comets or other astronomical phenomena, proved that cosmic bodies influence the course of history. No causal link between the appearance of a comet and subsequent events has been confirmed on a scientific or rational level. That is, comets do not impact human political life, just as human decisions do not alter the trajectories of cometary orbits. But it is the psychological power of these cosmic events, their unusualness and temporariness, that created a mirror effect, where events in the form of prophecies became self-fulfilling. People, succumbing to panic or hope, began to act as if the prediction was already coming true, creating a new fact of the future with their behavior. In such moments, history shows that everything seems more complex and tangled. The atlas in question appears at a critical moment when humanity stands at a crossroads of development. We find ourselves on the brink between terrestrial and interstellar existence. Significant discoveries have already been made. On Mars, we have found potential biosignatures that give hope for the existence of life. We are developing asteroid deflection technology, which significantly enhances the safety of our future. Serious planning for permanent colonies beyond its surface has begun. The appearance of a comet in these times is no coincidence. It coincides with one of the most significant events, the emergence. In those eras when humanity was only taking its first steps in understanding the surrounding world, science regarded mysterious cosmic phenomena with awe and reverence. Back then, people often explained unusual coincidences or synchronicities occurring in the celestial sphere through the intervention of divine forces or supernatural designs. In their mental constructs, ancient cultures sought the influence of higher powers, giving them meaning and explanation for everything that seemed beyond ordinary laws. These explanations served not only as a way to understand the incomprehensible but also strengthened the connection between humans and the surrounding universe, filling it with mysticism and sacredness. Modern civilization, armed with the scientific method and technological progress, strives to find similar explanations for what seems mysterious or unusual. Within the framework of scientific skepticism, we seek rational content in observed phenomena, as it is logic and evidence that allow us to expand the horizons of knowledge. At the same time, humans intuitively feel that there is something beyond mere coincidence, that some patterns in the cosmos may have hidden meanings and not be fully explainable through probability alone. Therefore, modern scientific thought attempts to unite both these approaches, the rational approach and the sense that deep mysteries may lie in the cosmos, beyond the boundaries of ordinary perception. The very name of the planet Mars, in honor of the Roman god of war, carries a rich cultural layer that significantly influences our perception and interpretation of the events around us. For centuries, the red planet has been associated with conflicts, struggles, changes, and inner transformation, both in mythological narratives and in the collective memory of people. These associations shape our attitude toward it, whether it be potential future landings or scientific research. When an interstellar visitor approaches the sky, people often involuntarily activate their mythological archetypes and cultural schemas. Within each of us, an internal image emerges, reinforced by centuries of myths and legends, even if we do not consciously notice it. This phenomenon occurs regardless of whether we acknowledge this process or remain modest in our knowledge. However, the most instructive and interesting aspect of this parallel is not the archetypal mythology, but the very dynamics of the human perspective on space and the development of methods for observing it. Each generation of humanity creates new devices and tools for exploring the universe, and with each new breakthrough, we are amazed to discover phenomena that were previously beyond the reach of our instruments. Radio astronomers discovered the existence of pulsars, rapidly rotating neutron stars emitting powerful radio signals, and space observatories have identified exoplanets, worlds orbiting other stars, which we could only dream of before. The modern network of numerous telescopes and satellites allows for the detection of interstellar visitors, large objects traversing interstellar space. This prompts reflection. Is it not a pattern that unusual objects appear at key moments of our expanding knowledge? And what if the pattern is not that these objects arise at special moments, but that the boundaries of our understanding expand so much that we begin to notice more and more significant phenomena that capture our attention? Perhaps millions of years ago, objects similar to Trojan asteroid bodies, now known as interstellar visitors, approached Mars just as frequently as today, and only now, thanks to advances in technology, have we acquired the ability to detect their chemical composition, understanding their significance in cultural and scientific contexts. This question provokes thought. If advanced civilizations exist in the world, where would they seek to hide their messages or clues for future generations? Or perhaps their clues are hidden in quite obvious ways and are perceived by us only after many years or centuries, when our methodology in the future must clearly and rigorously separate the stages of analysis and research. The primary task will be a systematic examination of possibilities, as well as their evaluation through the maximum use of existing data. In doing so, we will not blindly accept the patterns obtained as absolute truth. Instead, we will remember the important human tendency to seek meaning where there may be none, attributing special significance to random and even insignificant events. During the research, we will ask ourselves, what if, while strictly adhering to existing standards of evidence and scientific objectivity? The history of astronomy shows that even ancient researchers, who observed the movement of planets and recorded celestial phenomena in systems that initially seemed incomprehensible or even erroneous to them, were doing equally important work. These intuitive interpretations, though often incorrect, laid the groundwork for further discoveries. They created an observational base that eventually helped us discover something much more significant: the satellite orbiting our planet and later knowledge of interstellar objects. One could say that these initial attempts to recognize patterns in celestial phenomena were a training ground for the modern data search and analysis we conduct today. The current difference is that we have more advanced tools, more rigorous and methodical approaches, and standards in scientific work. However, at the core of human perception of cosmic mysteries, nothing has changed. We are still amazed by the grandeur of the vast universe, questioning our place in it and seeking answers. This process is an intrinsic inquiry inherent to humans from age to age. From time to time, the universe presents us with phenomena that seem almost too random to be mere coincidence. Such mysteries evoke wonder and a desire to unravel them. What if the ancient gods our ancestors depicted in myths were nothing more than descriptions of realities they could sense but not yet measure? Or, if we consider the hypothesis of the existence of a mysterious body, the so-called Atlas, we might wonder, could it be the very phenomenon that inspired myths about celestial messengers? Those that, seemingly observed since ancient times, played the role of such cosmic phenomena. Another important point is the story of Nibiru, Sitchin, and the connection with internet culture. Every few years, a new wave of popularization arises in the virtual environment regarding the theory of a supposed planet called Nibiru, which allegedly moves in an elongated orbit and periodically approaches Earth. These stories claim that it is the cause of myths about ancient astronauts, supposedly arriving from space, and that it is linked to genetic experiments, as well as the rise and fall of human civilizations. The main sources of these ideas are associated with the works of Zecharia Sitchin, who proposed the hypothesis that Sumerian cuneiform tablets supposedly contain evidence that ancient, advanced civilizations, called the Anunnaki, periodically visited Earth to mine gold and interfere with the human evolutionary process. However, scientists and official astronomical centers have expended considerable effort to refute these claims. The illusion of the existence of a mysterious planet that could collide with ours is disproven by numerous observations. Modern astronomy, through millions of hours of observation and complex research, demonstrates that to date, no signs of a rogue planet likely to collide with Earth have been detected. All gravitational and astronomical data indicate that there is no large approaching body in the outer regions of the solar system. Numerous telescopes around the world constantly monitor the sky, and none have detected such an object. It exists and is indeed observed in our universe, a fact confirmed by numerous astronomical observations independently conducted by various observatories worldwide. Scientists have tracked its trajectory, meticulously calculated it with mathematical models, and confirmed it with precise observation. Importantly, its chemical composition has been analyzed using the most advanced and sophisticated instruments ever created by humanity. allowing even the smallest details of its chemical makeup to be determined. This object, known as the triatlas, does not return to our solar system every 3,600 years, as it is not bound by orbits to our cosmic family. In fact, the hyperbolic trajectory of this object is essentially a one-way ticket. It arrives from interstellar space, moves according to the predictable laws of physics, and eventually departs forever into the depths of space, never to return. One might say that its path is the result of strict mathematical calculation, rather than mythological or mythologized notions. However, despite the apparent physical-scientific nature of such behavior, humans have a tendency to gravitate towards the idea of cyclicality in the cosmos. We tend to seek out recurring events because such a concept brings us comfort and a sense of control. We feel more confident if we imagine that even the grandest and most inexplicable phenomena are subject to some patterns that can be anticipated. The mechanism of this inclination is the desire to understand when the gods or cosmic messengers might return, to prepare for their arrival, or at least to reduce anxiety about the unknown. In this context, the assertion that such interstellar objects, like the triatlas, might return, or appear again, seems reasonable and logical. But the true nature of such objects is significantly more complex and diverse than mythological cycles. They appear suddenly, without invitation or warning, following trajectories determined by the laws of physics, not prophecies or handwritten predictions. When such an object leaves the system, it departs forever, disappearing into the vast and lifeless void of interstellar spaces. There is no predetermined cycle for it, no pattern by which its appearance or disappearance can be predicted. There are no guarantees or methods of preparation. All that remains is the knowledge that such an event can occur at any moment and at any point in the cosmos, and we, in turn, do not know when or if it will happen at all. Such unpredictability often seems more unsettling and frightening than mythical and often illusory cycles that create a sense of order and predictability. For although enthusiasts hope for the recurrence of visits from the giants of interstellar spaces, they at least know what to expect and when exactly. They have certain assumptions and guidelines. Triatlas, being a truly mysterious guest, only raises questions. Where did it come from? Why is its chemical composition so perfectly suited for restoring Mars' atmosphere? And what will happen when it invisibly approaches the red planet on its endless path to leave its traces or alter the atmosphere? The confrontation between scientifically grounded uncertainty and mythical legends and predictions perfectly demonstrates why it is so important to maintain critical thinking when it comes to cosmic anomalies and mysteries. Science, unlike pseudoscience, acknowledges its ignorance, proposes testable hypotheses, and is ready to constantly update its conclusions based on new data. It seeks to understand the nature of phenomena without resorting to claims that cannot be tested and rejects any interpretation that resists factual testing. At the same time, one cannot ignore the psychological needs of people who are driven to create multiple cycles and legends about cosmic phenomena. For a long time, astronomical observations have shown unusual phenomena that were difficult to explain within existing theories. One such phenomenon was demonstrated by the cosmic object, Oumuamua, which exhibited unusual acceleration in its movement. This sudden change in speed, completely uncharacteristic of classical solar system models, prompted scientists not only to ponder but also to conduct deeper research. Borisov, for example, behaved in space much like ordinary comets. It moved in a predictable orbit, came and went, leaving behind a standard trail characteristic of such objects. Meanwhile, other astronomical observations, such as those of the object codenamed ATL, demonstrated incomparably more astonishing properties, unusual chemistry, significantly different from familiar interstellar materials, and remarkable timing of arrival, which often defied all existing expectations. These discoveries, albeit in small volume, serve as an important example of how the nature of space can produce chemical reactions beyond existing models. However, even with all their uniqueness, this data is hardly sufficient for reliable statistical analysis that could confirm or refute hypotheses. But this is already enough to suggest that interstellar space may have a richer chemical composition than our theories previously assumed. When we talk about a cycle lasting approximately 360 years, it is important to understand that it is not related to the return of ancient astronauts or supercivilizations, but rather to the peculiarities of the development of human civilization itself. This cycle is determined by the duration of keeping written records, where the most important and complex cosmic events were documented. Thanks to these records, a picture of patterns observed in space gradually emerges, allowing us to identify recurring cycles and trends despite the scale of time. Over the past few centuries, humanity has been systematically observing celestial bodies, developing and implementing new tools that are increasingly powerful and sensitive to better understand what is happening beyond Earth. This constant progress allows for the discovery of new horizons of knowledge, expanding our understanding of cosmic objects and phenomena. But what if it is not about space at all? What if the important cycle is not related to astronomical events but to the development of the technologies themselves? Every few generations, humanity makes a qualitative leap in scientific capabilities, creating new instruments and methods that allow us to find, study, and analyze celestial phenomena with increasing precision. These technological breakthroughs provide access to previously unseen classes of objects and events that have always existed in space but remained inaccessible to our instruments or unnoticed. Radio observatories, for example, first discovered pulsars, rapidly rotating neutron stars emitting powerful radio waves, as well as quasars, bright and very distant cores of active galaxies emitting gravitational and electromagnetic signals. Thanks to space observatories, gamma-ray bursts, gravitational waves, and thousands of exoplanets, planets located beyond our system, which previously seemed unreachable, are now being identified. Automated sky survey systems today are capable of detecting and tracking even the smallest and fastest-moving cosmic bodies, such as asteroids dangerous to Earth, recording supernova explosions, and identifying interstellar travelers, rare and mysterious visitors passing through our solar system. All these achievements are linked to the possibility of continuous observation combined with high-precision analysis algorithms, allowing us to gain new knowledge at unprecedented speed and accuracy. In this evolution of technological progress, the latest stage has become particularly significant, a project called TRE-ATLAS. This unique development represents the pinnacle of modern achievements in astronomical technology, providing the ability not only to detect and track celestial objects. When we attempt to interpret contemporary scientific ideas through the lens of ancient texts, it often turns out that we learn more about our own assumptions than about actual historical facts. This is why studying such ancient sources is important not only for reconstructing the past but also for better understanding our own perception of the world. Modern science, including the concept of the Third Atlas, offers us a unique opportunity to practice the development of intellectual hygiene, which helps avoid hasty judgments and unfounded theories. We can acknowledge the unique properties of this phenomenon without resorting to hypotheses about ancient astronauts or other fantastical theories, which promotes a more objective approach to its study. At the same time, we can calmly explore its influence and significance for the chemical composition of the Martian atmosphere without claiming that such a phenomenon was specifically created to alter the planet. This approach allows us to ask profound, often philosophical questions about the nature of cosmic time and the mechanisms of interstellar delivery, while adhering to the strict standards of scientific evidence that distinguish science from semi-conscious speculations. The important conceptual cycle to understand is not the myth of the return of Nibiru or some cosmic cycle, but the human tendency to seek and find meaning in cosmic events. In our evolving ability to test these meanings against observable reality lies the key to understanding how closely our interpretations align with reality. As the Third Atlas and its associated ideas approach their still unseen encounter with Mars, we partake in the latest, oldest of humanity's intellectual traditions, observing the stars, seeking patterns, and attempting to understand our place in the universe. It is these phenomena, constantly challenging our notions of what is possible and impossible, that help expand the boundaries of our knowledge. The question is not simply whether we will discover patterns in the data. In the human mind, this is an automatic process. We constantly seek patterns, partly because it is inherent to our nature, and partly because it helps us structure the chaos of the surrounding world. But the main question is whether we truly find patterns that exist in reality, or if we have merely imposed our templates on random and often meaningless phenomena that only seem patterned because they align with our assumptions or expectations. This is part of an important reflection on the need to distinguish objective patterns from illusions created by our psychological perception. Further, in the section titled Artificial Transformation of the Planet, we return to the chemistry that lends the third atlas its particular mystery. The ratio of carbon dioxide to water, approximately 8:1, is one of the highest ever recorded in any comet. This fact is crucial for understanding if we imagine Mars not as it is today, but as it was billions of years ago and might become again. About 4 billion years ago, Mars had a dense atmosphere, rivers flowed on its surface, and in some cases, there might have been vast oceans. The traces of water erosion on the surface of the red planet are very well preserved. These are ancient river valleys, delta formations, and minerals that form only in the presence of liquid water. The area known as Jezero Crater, where the Perseverance rover is currently exploring in search of biological signatures, represents one of the few remaining areas of Mars past wet and more hospitable environment. But what happened to this abundance of water and dense atmosphere? Why has the planet transformed into the cold and barren place we see today? The answer lies in the fact that Mars lost its magnetic field in the early stages of its history, which led to its atmosphere, once much thicker and warmer, gradually thinning and disappearing under the influence of the solar wind over billions of years. If somehow the atmospheric layer of Mars could be thickened while preserving its chemical composition, there is a chance to slowly reverse its long process of sliding into a state where the planet becomes a bleak, cold, and lifeless world. Such a hypothetical scenario involves introducing specific components into the atmosphere that could activate or stabilize climatic processes and, over time, restore a more habitable atmosphere to the planet. A new concept has emerged in scientific horizons, 3I Atlas, representing a comet with an unusual substance content, among which the most notable is the gas most needed by Mars, carbon dioxide. To confirm this hypothesis, scientists used the results of the James Webb Space Telescope and SPHEREX instruments, which recorded an extraordinarily high concentration of carbon dioxide, as well as identified the presence of chemical substances such as carbon monoxide, sulfides, carbonyl, and water ice. This is essentially a set of chemical compounds specifically designed to impact the atmosphere, artificial or natural reagents capable of altering the chemical balance or initiating new chemical reactions conducive to forming more favorable living conditions. Undoubtedly, the scale of these processes plays a decisive role. A single comet, even with a particularly volatile rich composition, contains insufficient material to significantly impact the atmosphere of Mars. Over billions of years, the planet has been losing gases to the vastness of space, and even the largest deliveries of carbon dioxide by comets can be roughly compared to adding a teaspoon of sugar to a giant Olympic pool. The effect is overshadowed by the scale of the complexity of the problem. However, what if the event associated with this cometary body is not singular, and the component we observe is just part of a larger and more prolonged process? Such a thought experiment prompts consideration of strategies for gradually restoring Mars' atmosphere over geological timescales. Regular deliveries of carbon dioxide-rich materials could become a key element of this long-term program. The idea does not suggest a rapid transformation of Mars into a habitable space. It is too complex and lengthy a task, but such an approach could significantly push the evolution of the atmosphere in a more life-friendly direction. The heating patterns recorded in notable spectroscopic data from the shape of 3IATLS support this hypothesis from a scientific logic perspective. The closer the comet approaches perihelion, the stronger the solar heating grows, which in turn leads to the maximum possible gas release at this stage. This becomes particularly important when the comet is at its closest point to the Sun, creating the necessary conditions for the most efficient delivery of gases, whether carbon dioxide or another volatile component, into Mars' atmosphere. The orbit's geometry provides optimal conditions for this process, and fresh spectroscopic data have revealed another intriguing complexity in the comet's chemical composition. In addition to the predominant carbon dioxide, instruments have detected the presence of organic compounds that could serve as building blocks for further development of more complex chemistry in the atmosphere. The detection of carbon monoxide indicates specific conditions of this comet's formation, significantly different from those familiar to objects orbiting within our solar system. The green glow recorded in September adds another layer of mystery to this impression. Although the exact molecular mechanisms causing such coloration have not yet been conclusively confirmed, there is speculation that it may be related to cyanide compounds or dicarbon molecules, which significantly expands the possibilities for understanding chemical reactions potentially involved in the process of transforming Mars' atmosphere. These chemical reactions would be crucial for developing projects for colonization and creating a habitable atmosphere, even if their occurrence happens under natural conditions. However, it is important to exercise caution when interpreting such data, avoiding erroneous assumptions. If we consider the nucleus of a comet as something covered with a dense layer of carbon dioxide ice, such a coating can significantly influence the processes related to the release of internal water reserves, which are in a frozen state. As a result, this icy crust acts as a kind of barrier, suppressing the release of deeper reserves containing water and possibly other volatile substances. This, in turn, creates the characteristic ratio of chemical elements and compounds observed as the comet approaches the Sun. As the comet, designated in this hypothesis as the 30th ATLS, continues to approach its perihelion, its surface is thoroughly heated, and a gradual change in chemical balance occurs, revealing the internal, previously hidden layers of its frozen formation history. At this point, the dynamics of gas release come into play. These processes reach their peak and create conditions under which a unique chemical ratio is observed from Earth. Some studies suggest that it is during the peak activity of the comet that its closest approach to Mars coincides, and this is quite an important coincidence, since at this moment, the chances are highest to observe what gases it emits. However, it should not be forgotten that Earth-based telescopes will not be able to see the comet directly at its closest approach to the red planet, as it will be hidden behind the solar shadow or positioned in a way that obstructs observation from Earth's surface. This feature essentially creates ideal conditions for observational studies, a window when the comet is in its most active and chemically rich phase of passing through the solar system, yet remains hidden from Earth-based observers. In the realm of science fiction scenarios, such an event could be imagined as a meticulously programmed interstellar transport, designed to deliver targeted components into the atmosphere of a target world while minimally revealing its activity in areas accessible to external observation. In such a hypothetical case, everything, from the chemical composition to the timing of gas release and their direction, is carefully selected to ensure maximum effect with minimal likelihood of detection. However, in reality, the entire system exists due to the laws of physics and orbital mechanics, not by the will of an artificial intelligence. Orbital characteristics and the relative positions of planets and comets, all of this is predictable and arises from the laws of gravity. The solar conjunction hiding the ATLS comet from observation from Earth is the result of the movements of planets and bodies within the framework of physical rules, not evidence of an intelligent designer. The release of carbon dioxide from the core of the comet is not a sign of intentional design, but a consequence of the processes that occur during the formation of such objects in regions of distant star systems. In these conditions, compositions are formed, determined by the conditions of cold, star-distant core processes. And yet, despite the natural nature of such coincidences, some of them seem strikingly precise, almost satirically hitting the mark. For example, an interstellar object loaded with greenhouse gases appears in the place and at the time when scientists notice possible signs of life or biosignatures on Mars. Its chemical composition seems to be determined by those compounds that should help Mars restore its atmosphere, if it were able to do so. And its trajectory of approaching the red planet occurs precisely during the period when the maximum solar heating is observed on the surface of Mars and simultaneously the minimum opportunities for conducting observations from Earth. And it is at this time, when the comet comes closest, that our orbital devices, such as the European Space Agency and its Martian satellites, represent our last chance to uncover all the mysteries of this enigmatic visitor from interstellar depths. Devices located in Mars' orbit should be able to identify and analyze chemical signatures indicating possible mechanisms of gas release from the comet. For example, Mars Express is undoubtedly one of our best hopes. Discussions concerning theories of planetary terraforming are often based on speculations that, from a scientific point of view, turn out to be quite dubious. However, these hypotheses play an important role in shaping our imagination and reinforcing narrative schemes about possible scenarios for transforming alien worlds. They make us perceive Mars not just as a time-frozen repository of ancient fossils and remnants of the past, but as a dynamic, changing world capable of transformation and rebirth. The intense discussion about the potential of this planet suggests that Mars is not a static spectacle, but a potentially habitable or inhabitable object that can be given new life by changing its atmospheric composition. The basis of such hypotheses lies in the confidence that the chemical composition of the red planet's atmosphere, including carbon dioxide, water vapor, and organic compounds, is the raw material necessary for restoring and transforming the atmosphere in a direction favorable for life. These components can come from both natural interstellar processes and human-created space exploration projects. The crucial idea is that chemistry, its fundamental basis, remains unchanged regardless of the source of these substances. Imagining potential scenarios, one can use a model similar to the 3I Atlas, which demonstrates how the influence of various factors could transform Mars' atmosphere. Even if such changes occur through natural processes, such as the impact of comets with a rich chemical composition, these events can lead to atmospheric thickening and increased organic complexity, which is precisely what early terraforming projects focus on. As the scheduled meeting in October approaches, the question arises, can the 3I Atlas model show changes significant enough to generate substantial interest? Or will the scale of impacts and the processes it illustrates be too small to create dramatic transformations in the planet's atmosphere and surface? The main question is not whether Mars will change radically, but whether this process will teach us about the atmosphere and how it can be transformed. We can analyze the chemical reactions observed in the models and draw conclusions about the possibility of more accurately restoring the planet's atmospheric system, about how interstellar materials, including comets and asteroids, can serve as sources of necessary ingredients. They provide a unique opportunity to understand which chemical compounds and materials can be involved in the process of transforming the habitability of another world. Discussions on terraforming are complemented by the notion that the true transformation of a planet often occurs in the minds of researchers and scientists, as models like 3I Atlas help envision not only the current level of knowledge but also the prospects of how Mars could change. These models often evoke the image of a less static object than we are used to seeing, but rather an infrastructure for habitation, where chemistry becomes the foundation of life, and the atmosphere, a living organism capable of supporting a new biosphere. The next important topic is the so-called biological connection, panspermia, and the role of switches, as well as the genetic code that links the past, present, and future. It must be clearly emphasized that, to date, no direct evidence of living organisms or biomaterials has been found in models like 3I Atlas. The hostile environment of interstellar space completely destroys most biological molecules over the millions of years required for interstellar travel and the spread of life. The cosmic environment, its cosmic radiation, extreme temperatures, and vacuum conditions make the existence of any living cell practically impossible over long periods. However, the absence of direct evidence in no way negates the statements about possible directed panspermia, the hypothesis that life could have been spread between planets and star systems intentionally, rather than accidentally. Assuming that an advanced civilization wished to spread life, this randomness seems more like a manifestation of conscious design rather than mere coincidence. In the world of modern molecular biology, outdated notions of so-called junk DNA have long been debunked, and today researchers know that vast stretches of the genome, previously thought to be meaningless and non-functional, actually contain many crucial elements. These regions often serve as regulatory sequences controlling gene activity, structural elements responsible for chromosome organization, and evolutionary artifacts carrying significant information about a species' past. Today, there is no reason to consider these areas of the genome as useless junk. On the contrary, many of them perform key functions, ensuring the stability and adaptability of organisms. In such a situation, the idea of a hidden code or software in genetic material awaiting activation no longer seems like fantasy, although there is still no direct evidence of complex, dormant systems of interstellar software. In the public consciousness, this metaphor remains a useful tool for contemplating the hidden potential of biological systems that may be awakened under the right conditions. As for planetary bodies like Mars, it may contain on its surface or within its depths peculiar switches of biological activity that can be activated by specific chemical triggers. The detection of potential biosignatures in Jezero Crater on Mars suggests that this planet once had conditions suitable for the emergence and development of life. And what if within its depths or on the surface there remains an unactivated, dormant, biological potential? Perhaps there are remnants of complex molecules or structures waiting for the right conditions to reactivate, when the atmosphere becomes less hostile and the climate more conducive to life. Although all this may sound like pure speculation now, the reality is that ideas of this kind go far beyond hypothetical assumptions and require serious research. However, it is important to remember the mirror effect. Human attention, research, and investment ultimately determine what happens with possible forms of life beyond Earth. The discovery of potential biosignatures on Mars has sparked a wave of interest, energized the scientific community, increased funding for sample collection and return missions to Earth, and attracted public attention to the question of life beyond our planet. It is thanks to this perception and investment that there is an understanding that astrobiological research is more important than ever and that we are approaching new discoveries. Moreover, the image created by hypothetical notions of alarming signals and unusual chemical properties can activate new forms of behavior in humans, broaden horizons, and encourage further research. These ideas and concepts not only inspire the scientific community but also shape narratives that make our view of Mars more enriched, more vivid, and more dynamic. It ceases to be perceived as a dead void and transforms into a potential arena for the search for life, hidden within or on the surface. This approach helps to form a more intuitive understanding that Mars is not just a silent body but an object with a rich history and hidden potential that may manifest when conditions become more favorable. The history of the panspermia hypothesis, first proposed by Swedish scientist Svante Arrhenius in the early 20th century, speaks both of an incredible idea and a serious scientific assumption. According to it, life could spread throughout the universe, with the help of comets, asteroids, and other meteoritic bodies. This hypothesis suggests that organic materials and even living organisms could be transferred from planet to planet, traveling across interstellar distances. Most scientists are skeptical about the so-called natural panspermia. The real test of our capabilities and knowledge will only occur when we can obtain samples directly from objects belonging to the Triassic or other similar interstellar visitors, cosmic bodies that arrive in our solar space from distant corners of interstellar substance. The European Space Agency has confirmed that, at present, it is practically impossible to organize a mission to intercept such an interstellar object, as it is an extremely complex task both technically and logistically. However, the prospects of gaining such a unique opportunity do not disappear. In the future, interstellar bodies may become the most valuable sources for direct analysis, as they carry materials unaltered by Earth's processes and atmosphere. At the same time, the anticipation of working with interstellar objects is associated with the hope that they can provide indisputable evidence of the presence or absence of ancient extraterrestrial biological life or biological signatures preserved in interstellar particles. One of the most promising options is the Mars Sapphire spacecraft, whose launch, although delayed, is still planned for the early 30s of the 21st century. It will give us a magnificent opportunity in the future to test the hypothesis of the existence of ancient biology on Mars. The samples obtained or data collected with this apparatus will allow the exploration of possible biosignatures, that is, signs indicating the presence or past existence of life on this planetary surface. For example, textural images, such as leopard spots found in Martian clay sandstones, may contain preserved cellular structures, organic molecules, or isotopic signatures within them, all of which could serve as compelling evidence of biological origin. Assuming that life once existed on Mars, even if it disappeared many billions of years ago, its geological layers might preserve dormant genetic material or biological remnants. In the event of restoring an atmosphere that once hosted life, theoretically, some biological processes could be triggered, leading to the revival of microscopic organisms or their traces. Such ideas, although highly speculative, are based on the principle of the possibility of reviving life that seemingly vanished from this world long ago. Ultimately, Earth's subsurface layers, for example, may conceal microorganisms that have been there for millions and billions of years, remaining in a state of dormancy, awaiting conditions favorable for revival or activation. It becomes intriguing to understand that the connection between interstellar chemistry and terrestrial biology may be much finer and more complex than the simple assumption of direct colonization of planets or their inhabitants. Samples of complex organic molecules formed around other star systems could serve as raw materials for prebiotic chemical processes on worlds like Mars. In an atmosphere containing carbon dioxide, methane, and water, components we encounter today in samples like the 3 Atlas, lie the fundamental building blocks necessary for the formation of life. These elements are a potential basis for chemical reactions that ultimately lead to the emergence of living organisms. At the same time, it is important to exercise caution and not rush to conclusions. It must be remembered that coincidences and random occurrences that appear as signs of biological processes do not always indicate the presence of true life or intentionally created biological traces. The universe possesses a colossal reserve of organic chemistry, and the prevalence of life's building blocks in interstellar space is immense. In many cases, it can be said that the abundance of organic molecules and prebiotic compounds found in space would indicate that such places could become potential sites for the emergence of life. It is especially important to emphasize that the arrival of comets or meteorites rich in carbon on potentially habitable or previously habitable worlds could contribute to this potential. A thoughtful and reasonable short-term experiment aimed at identifying biological connections would involve conducting spectroscopic analysis of specific spectral signatures corresponding to the 3 atlases to detect the presence of amino acids, nucleotides, or other complex organic molecules that serve as indicators of active biological processes. Modern scientific instruments are capable of accurately detecting such compounds if they exist in atmospheres or substances in sufficient concentrations, significantly expanding the possibilities of searching for signs of life on other planets or celestial bodies. Thus, space probes planned to study the 3 atlases during their anticipated encounter or passage could potentially detect biological signatures if the comet emitted complex organic substances, evidence of possible biological or prebiological processes. In this direction, a spectrometer specially designed for atmospheric chemistry analysis, known as the trace gas orbit, plays a particularly important role, equipped with high-precision spectroscopy to detect and measure extremely low concentrations of gases and organic compounds. This instrument is one of the best in the world for such purposes and could be key in detecting traces of biological activity. Although it is still unknown whether the 3 atlases contain any biological materials or signs of life, their arrival has already prompted deep reflection and reconsideration among humanity. It has awakened an awareness that we live in a universe where interstellar chemistry and planetary biology are so closely linked that they can open new horizons of understanding for us. These thoughts about life potentially being widespread across different parts of the cosmos prompt consideration not only of specific objects like comets or asteroids but also of more global questions on a universal scale. The question is not whether the 3 atlases will ever visit Mars or another planetary body. Evidence suggests they are unlikely to do so. The real question is whether their arrival will inspire human curiosity, resources, and determination necessary to answer deeper and more important questions regarding the spread of life in the universe. We may lean toward the idea that our notions of the origin of life are merely incorrect myths or mythological models, akin to a snowball that appeared by chance and continue to significantly transpose them onto real cosmic objects. However, perhaps we are already developing the scientific tools and methodologies that will allow us to find genuine biological connections between worlds, revealing hidden signs of life or activity where previously thought impossible. In this view, the answer to the significance of the three atlases depends not so much on what they bring but on our readiness to search, the ability to notice, interpret, and comprehend those small signals that testify to the profound influences shaping us and our view of the universe. For a moment, stepping away from the narrow framework of astronomical research, it is worth considering a broader aspect: how the narratives and myths we create around cosmic events shape not only our perception of the world around us but also guide our behavior. In the personal lives of individuals, as well as at the level of civilizations, the stories we tell about space and its mysteries have a powerful influence on our actions and decisions. They not only reflect our knowledge of the universe but also actively affect how we respond to new information, allocate resources, and choose priorities for future development. Consider, for example, the stories associated with comets and how our views on them have changed over millennia. Halley's Comet, which appears approximately every 76 years and is one of the most famous astronomical objects in human history, evokes different feelings and interpretations depending on the time and cultural context. In medieval Europe, people saw it as an omen of tragedies, plagues. Modern media algorithms significantly amplify the evolution of the narrative, giving it new and often unexpected forms of development. In the era of digital platforms, social networks stimulate the spread of the most extreme interpretations and emotionally charged messages, surpassing in effectiveness the deep, balanced, and scientifically grounded analysis. Imagine a situation where a single post claiming that an object designated as 000 or 3ATLS is an alien artifact can reach millions of users in just a few hours. Such a post can instantly spread across the internet, causing a wave of speculation, while serious scientific articles that thoroughly explain its possible natural origin remain virtually unknown to the general audience, as they are published in specialized academic journals read by only a few hundred scientists and specialists. This creates a dangerous vicious cycle where sensational interpretations of real scientific mysteries displace or ignore more subtle and nuanced analyses of the situation. As a result, the ratio of informative signals to false or distorted messages deteriorates. Speculative hypotheses spread faster than scientific verification, making it difficult for non-specialists to perceive the differences between genuine scientific uncertainty and artificially created controversy aimed at sensationalism or misinformation. Speaking of the modern global context, one cannot fail to mention the interstellar security systems that have been developed and successfully implemented recently. These systems, the result of joint efforts by international organizations and scientists, serve as a kind of shield, protecting humanity from sudden cosmic threats. Among them are, for example, asteroid collision networks with Earth, such as the Atlas network, as well as programs like Pan-STARRS and similar systems, which conduct automatic monitoring of the entire visible part of the sky. They scan it almost every night, continuously detecting and tracking potentially hazardous space objects. Thanks to such a global observation mechanism, the risk of sudden impacts and cosmic catastrophes has significantly decreased. However, the implementation of these technologies has also given rise to new forms of public consciousness and awareness about possible celestial visitors. We live in an era where discovered interstellar objects, such as the 3 Atlas, after their first sighting and discovery, enter a data array quickly analyzed by specialists. Preliminary orbital calculations, chemical analysis, and risk assessments are published within days or even hours after detection, ensuring a speed of scientific information exchange at unprecedented levels. This data flow fosters the development of international scientific cooperation, allowing scientists, engineers, and security specialists to combine their efforts. However, at the same time, the rapid exchange of information creates new opportunities for misinterpretations, rumors, unfounded hypotheses, and premature speculations. One of the main challenges remains the need to maintain a level of scientific rigor and critical thinking, recognizing that our understanding of interstellar chemistry, as well as the frequency and nature of such objects' visits, is still far from definitive certainty. The object named 3 Atlas does not fit into the usual categories of known celestial bodies. Its chemical composition is unusual, the timing of its appearance in scientific observations seems random, and its behavior during the encounter with Mars will occur within timeframes limited by ground observation capabilities. These uncertainties create a slight space for scientific speculations and hypotheses, which often cannot be verified or refuted. In such conditions, the discussions and assumptions arising in scientific circles justifiably find fertile ground for the emergence of unfounded conspiracy theories and the popularization of unscientific interpretations. The key in this process is the development and improvement of tools that allow distinguishing productive uncertainty, the kind that drives new discoveries and stimulates public support for space research, as well as efforts to detect asteroids and study Mars, largely depends on how convincingly we craft stories about the reasons these areas of scientific activity deserve attention and funding. One of the tools that highlight the practical significance of astronomical observations is the Tri-Atlas project. It provides an opportunity to demonstrate how the study of celestial objects benefits us, while simultaneously highlighting the scientific mysteries and enigmas that make space exploration so intellectually captivating and engaging. At the same time, creating such narratives comes with a certain responsibility. By emphasizing the mystical and dramatic aspects of celestial bodies, we risk creating inflated expectations that may not be met. For instance, if an object pointed out by the Tri-Atlas project turns out to be just an ordinary comet with slightly unusual chemistry, public interest in interstellar visitors will undoubtedly wane. In such a situation, support for further observations and research may also decline, as mystery and intrigue are crucial components of our motivation and interest in space. A well-founded conclusion can be drawn only by knowing that turning a mystery into a mundane fact will reduce the appeal of scientific articles and research. To assess anomalies in celestial objects, it is useful to have several key tools at your disposal. Among them are verifying the source of information, the ability to analyze statistical data, the capability to make predictions, and a tolerance for uncertainty. In this context, statements about Tri-Atlas should be considered with regard to their origin. Peer-reviewed articles hold much more authority than social media and internet posts, and official statements from organizations like NASA or the European Space Agency deserve more trust than anonymous speculations and rumors spread online. Statistical literacy helps distinguish truly unique anomalies from the effects of random or biased data samples. In the case of Tri-Atlas, it is unusual compared to the 3 interstellar objects we have already discovered, but it is important to remember that 3 observations are too small a sample to draw definitive conclusions. As detection methods improve and more data is accumulated, this object may not be as exceptional as it currently seems. By making predictions about the future and modeling the possible behavior of Tri-Atlas as it approaches Mars, we can separate real scientific hypotheses from speculative assumptions that cannot be tested. Theories that provide clear, testable predictions, such as how the object will behave upon contact with a planet, can be confirmed or refuted as new data emerges. Reliable hypotheses, those that remain valid even after empirical testing, are always more valuable scientifically than theories that cannot be falsified. A crucial skill for a researcher of cosmic mysteries is tolerance for uncertainty, as the universe constantly presents us with phenomena that challenge existing scientific theories, not always requiring complex explanations. Sometimes, the reason behind the mystery of Tri-Atlas may be that current technologies and observational capabilities do not allow us to fully decipher its nature and behavior. The meta-level of analysis is also important here. Comments on how algorithms govern the dissemination of information and how Tri-Atlas stories emerge in digital network ecosystems significantly help in understanding current processes. Platforms focused on capturing attention and increasing audience engagement often operate in a way that does not always prioritize data accuracy, creating mechanisms where sensational and emotionally charged interpretations have a better chance of being noticed and discussed. This approach encourages the creation of visual and narrative stories that can often confuse or distort real scientific facts. Understanding these systemic biases and features of information dissemination helps us Visual communication is a powerful tool destined to shape our perception and interpretation of the most mysterious aspects of space and the universe as a whole. The importance of this impact is hidden in the subtlest nuances. When we try to understand what lies behind the unfathomable mysteries of space, our choice of ways to present information, whether strict scientific images created using spectroscopy and other precise methods, or vivid, emotionally rich artistic interpretations, affects how a person perceives and comprehends this information. This subtle, sometimes imperceptible, but extremely significant moment is especially evident when comparing different ways of presenting data to a wide audience. Looking at real spectroscopic indicators that record the composition and properties of cosmic objects, or artistic versions of hypothetical alien artifacts, it is easy to see how significantly the presentation format influences. Against the backdrop of the upcoming October meeting, where the topic of research and the possible confirmation or refutation of hypotheses about the nature of a certain cosmic anomaly becomes increasingly relevant, it is especially important to understand how these narratives are formed. Three possible scenarios unfold around the hypothesis. Either the evidence suggests that the object is a natural result of natural processes, such as a comet, or the data points to something exceptional, phenomenal, or it is just part of a more complex picture, including additional information that helps illuminate our knowledge but does not provide a definitive answer. This story becomes not only scientific but also public. How we report the results and interpret them can significantly influence broad segments of the population and political decisions. Public support for further space exploration, international cooperation on planetary protection, and funding for scientific programs directly depends on how this story is presented and the meanings attributed to it. The stakes in these narratives are comparable in importance to the scientific discoveries themselves. It cannot be ignored that the latent power of these narratives extends beyond immediate political consequences. They shape our collective understanding of humanity's place in the universe, our responsibility as a cosmic species, and our readiness to encounter truly unusual, even anomalous phenomena. The topic of potential encounters with extraterrestrial civilizations and discussions about speculative hypotheses generate a key understanding: the importance of not only searching for external signs of life but also the ability of the human mind to respond to cosmic ambiguity. Perhaps the lessons this research story teaches us are not about interstellar chemistries or terraforming Mars, but about how we perceive, react, and adapt to the complex, often unpredictable cosmic reality, which is frequently more mysterious and unfathomable than it appears at first glance. Speaking of the hypothesis of an earlier development cycle, it provides an unexpected yet intriguing twist in interpreting the enigmatic data of the third astrobiological system, the so-called Third Atlas system. This theory allows for the explanation of the unique timing of formation and unusual chemistry of the object without the need for extraterrestrial intervention and intelligent beings behind its origin. Imagine if the aliens responsible for atmospheric changes or the creation of complex chemical compounds were not aliens at all, but rather ourselves, or representatives of a very early and advanced human civilization that achieved interstellar technologies hundreds of thousands or even millions of years ago. This civilization may have experienced a catastrophe, a large-scale event that virtually erased most traces of their technological legacy from the geological record. It is intriguing to speculate that this earlier civilization might have deployed systems that autonomously manage planetary atmospheres or cosmic spaces on interstellar scales over infinitely long periods. Perhaps their automated systems for maintaining habitable conditions have been operating for many years. Scientists and enthusiasts of mysterious phenomena have observed a series of signatures over the years that are difficult to explain within the framework of known natural processes. Among these are unusual isotopic clues found within the scope of major nuclear events. Their unique isotopic profiles and distributions suggest that this signature could be the result of some powerful nuclear reactions that possibly occurred in the distant past, such as massive stellar explosions, catastrophic collisions, or other cosmic events. Similarly, on the surface of our Moon, there are traces of artificial structures or materials that are hypothesized to have remained there for millions of epochs, unless geological processes have completely destroyed them. These remnants, serving as objective witnesses of possible ancient activity, differ from natural formations in their composition, structure, or unique interdisciplinary characteristics, making them potential confirmations of intelligent intervention. Additionally, in some cases, space debris is found associated with infrastructure created by humans or supercivilizations. These are fragments of satellites, space stations, rocket particles, and other technical devices lost or left in interplanetary or interstellar spaces. These debris, even after long periods in space, retain their structural and chemical properties, suggesting their artificial origin, since natural objects typically undergo shrinkage, erosion, and change under prolonged exposure to cosmic factors. In the context of searching for signs of extraterrestrial life or left-behind technologies, genetic engineering and modifications of living organisms hold a special place. In some cases, forms of terrestrial life have been found whose genetic code contains anomalous combinations or mutations that cannot be explained by natural selection. These facts suggest that in the past, there were efforts to apply genetic engineering to create species that surpass naturally occurring ones in their characteristics. Moreover, some forms of life reflect signs of deliberate changes, which heightens the suspicion of artificial intervention. It is interesting to note that none of the described clues have been fully convincingly confirmed or unequivocally recognized by the scientific community. However, despite the lack of definitive evidence, each year our ability to detect subtle traces of long-vanished technologies, species, or ancient civilizations significantly improves. Modern methods, as well as the development of new technologies for data analysis and interpretation, allow us to better distinguish true signs of artificial origin among superficial, natural formations. At the same time, it is important to emphasize that the absence of convincing evidence that such civilizations truly existed does not mean their complete absence in the past. On the contrary, this is a limitation on the scale, the time of their activity, and the possibilities of their manifestation, since the traces left initially could have been destroyed by time or the technological conditions of planets and stars. Now, let's assume that such a sufficiently advanced civilization could have existed, possessing the capabilities for interstellar travel and the colonization of entire systems. In this context, the question becomes, could there have ever been a desire or necessity to restore the habitability of planets like Mars? And if the answer is affirmative, how could this have been realized? After all, Mars is the closest planet to Earth, located in the so-called habitable zone of our solar system, an area where the temperature and conditions potentially allow for liquid water and, consequently, support biological forms. Historically, it is known that in the distant past, billions of years ago, Mars had a denser atmosphere and a significant amount of water on its surface. These conditions created the prerequisites for the emergence of primitive life forms and possibly even the development of more complex organisms. Modern human civilization, with sufficient knowledge and resources, might consider Mars as a priority target for global projects aimed at restoring its atmosphere and climatic conditions. This could involve deploying automated systems capable of functioning for millions of years. 3 hypotheses related to the supposed engineering interventions in the atmosphere of Mars do not correspond to any of the known characteristics we are accustomed to. However, this hypothesis deserves comprehensive consideration, as it can offer an answer to one of the most profound and complex questions related to the origin of time and chemical processes occurring in our universe, without the need to assume the presence of external intelligent beings. If we consider the hypothesis that in the distant past, perhaps even millions or billions of years ago, representatives of intelligent beings appeared on Earth or other planets, who developed modern or nearly modern methods of atmospheric control and management, then Mars would certainly represent a logical first point of industrial or research interest within the entire solar system. After all, the planet located next to Earth is the most accessible for conducting interplanetary experiments and technological projects. It should be noted that the coincidence between the discovered biosignatures of Mars and possible traces of interstellar deliveries of atmospheric substances may indicate the presence of deliberate or even systematic coordination between these rapidly developing systems, possible predecessors of our civilization, or interstellar engineers carrying out management. This model explains why the emergence of a hypothetical system, designated as 3 atmospheric controls, seems quite natural from the perspective of modern instrumental methods and means of observation. At the same time, it demonstrates properties that seem almost supernaturally convenient and wonderfully coincidental, raising concerns about the potential deliberate concealment of its presence, especially by those systems that consciously attempt to avoid detection by developing civilizations not yet ready to encounter a millennia-old technological legacy. This complex strategy of concealment could be specifically implemented for pedagogical reasons. It is meant to convince developing civilizations of the necessity to undergo a long journey of knowledge and scientific maturity before granting them access to the full picture of their technological heritage. Thus, the hypothetical 3 atmospheric controls system acts as a sort of cosmic exam, testing whether modern humanity possesses the observational and analytical skills to recognize, interpret, and adequately respond to potential assistance or intervention in atmospheric management. The testability of this hypothesis, and simultaneously its weak point, lies in the possibility of detecting hidden signs of engineering interventions that might be imperceptible to our current instruments and methods. We are capable of searching for individual signs, such as narrowband radio signals, structured variations of light, and chemical compositions that change or react to the approach of Mars. Any such anomalies could indicate unnatural, specifically artificial, atmospheric management. In other words, traces of long-existing unnatural mechanisms integrated into the planet's structure to provide covert support or regulation of its atmosphere. The most important tool in this area is the European Space Agency's orbital apparatus, providing a unique opportunity to detect such signatures during the upcoming October mission. If the 3 atmospheric controls system indeed functions as an engineering system designed for substance delivery and controlled atmospheric impact, then at the moment of closest approach to Mars, unique features in behavior patterns, targeting mechanisms, chemical release methods, and communication protocols that are clearly uncharacteristic of natural comets or meteor objects could be detected. However, even found evidence of engineering intervention cannot serve as definitive proof that humanity or its predecessors are the sources of all these hypothetical processes. Advanced atmospheric restoration technologies could have been developed by any possible forms of life that achieved technical maturity before our time. On a galactic scale, which has existed for billions of years, there have been countless civilizations capable of interstellar engineering projects, experiments, and experimental interventions. That is why the hypothesis that the 3 ATCs, automatic transport systems or similar advanced technologies, are the result of intervention by extraterrestrial civilizations would ideally suggest that these technologies have some recognizable human nature, being, so to speak, closer to our concepts and ideas, rather than being completely alien or extraterrestrial in essence. It is simpler and psychologically more comfortable to imagine that these capabilities and techniques arose from our own long development and forgotten epochs, rather than encountering completely alien engineering solutions that appear foreign and incomprehensible. This does not make the hypothesis more scientifically grounded or convincing, but it explains why people find it more natural to assume a civilization created by humans or human-like beings with advanced knowledge, even if the technological requirements and scales of the achieved systems are roughly the same in both scenarios. When considering such a scenario, it is necessary to take into account not only the period of flourishing and subsequent decline of that advanced civilization that might have left these mysterious systems but also the features of deploying interstellar engineering structures that could continue to function for tens, or even hundreds of thousands of years, despite planetary collapse. No geological record on Earth indicates the presence of a civilization that reached industrial technologies before humans appeared, but cosmic civilizations might leave far fewer traces on the planet. Their activities could have been minimally noticeable or hidden. Alternatively, the hypothesis suggests that such a highly developed civilization might have originated on Mars during a more habitable period in its history, when the climate and atmosphere were significantly better than today. If intelligent life existed on Mars in the distant past, possessing interstellar capabilities before the planet suffered a catastrophic atmospheric collapse, then this civilization might have deployed long-term recovery systems designed to gradually transform Mars back into a habitable environment. This version explains why the technologies enclosed in the system designated as the 3ATCs seem chemically and technologically perfectly compatible with the settings and characteristics of the Martian atmosphere of that time, and also fits the proposed timeline of events. Automated systems could have been programmed to activate the delivery or launch of their mechanisms upon detecting signs of renewed life or biological activity. For example, the arrival of new cosmic civilizations ready to assist in recovery, or other signs that the planet has once again become attractive for life. The concept suggests that these systems could have remained dormant for millions of years, waiting for contact with the outside world and responding only to certain signals indicating the need for recovery. Of course, to date, we have no conclusive evidence that intelligent life ever existed on Mars, although current knowledge of the planet's atmospheric evolution implies that complex ecosystems had a very narrow window to develop before conditions became too harsh to support stable life. The lack of confirmation does not necessarily mean that these systems or civilizations could not have existed, as such activities focused on interstellar travel and long-term technology storage could have left very few traces on the planet's surface. The engineering challenges associated with programming interstellar comets or other cosmic objects for precise delivery are tasks of the highest complexity and remain out of reach for any civilization, regardless of who created them. Trajectory correction of interstellar traveling objects, chemical and environmental protection, ensuring long-term system stability over vast distances, all require technologies that represent the pinnacle of engineering prowess during millions of years of space travel and the mechanism of synchronizing operations that activate delivery sequences, a feat currently unattainable for modern humans. Nevertheless, there is an opposing hypothesis that all these signs, chemistry, structure, and timing, are merely coincidental, the result of a rare confluence. The question concerning the likelihood that an interstellar visitor, or so-called guest flying object, arrived with a finely tuned set of chemical elements and compounds to capture potential signs of life or biosignatures on Mars seems almost incredible. To dare to suggest that this is exactly what happened complicates understanding doubly, for the probability that these alien travelers carry precisely the chemicals needed to restore the planet's atmosphere at the moment we detect the first signs of possible biological activity seems not only very low but astronomically, almost impossibly, high. Perhaps the most important and complex question is not whether triangular astrobiological signatures are artificial objects indicative of an alien civilization. It is far more important to understand whether we are ready to acknowledge that the implementation of engineering solutions capable of justifying large-scale and long-term atmospheric restoration projects may well be beyond our existing technological capabilities and knowledge reserves at this time. Advanced methods aimed at returning the planet's atmosphere to a life-friendly state may prove so complex and subtle that they appear as natural processes to civilizations that have reached interstellar horizons. The theoretical model suggests that such advanced engineering achievements can mimic natural developments, creating the impression that restoration processes are natural rather than the result of deliberate intervention. The hypothesis that earlier civilizations are intelligent existences with similar engineering expertise could have existed before us, offering solutions for atmospheric management, creates an intriguing intersection between random coincidence and conscious intervention. This approach allows the enigma to be perceived as genuine and yet contemporarily explainable, maintaining a balance between mystery and reasonable technological achievements. In this context, the universe seems more comfortable and understandable, as it represents a harmonious blend of assumptions about random natural processes and the possibility of technological intervention, leaving a smaller footprint than might appear. But the question arises, is such comfort a manifestation of wisdom or the result of self-deception? The answer to this question remains unclear and is yet to be determined in the future. As we approach the moment when the three asteroid transformer systems, or 3ATS, engage in their almost invisible, mysterious encounter with Mars, we increasingly understand that this meeting may reveal much more than meets the eye. We face the possibility that we are not merely observers, but in essence, participants in a history whose magnitude and antiquity may far exceed our boldest assumptions. This encounter could be the key to understanding that a comet or interstellar object, moving towards us, can deliver not only chemicals for atmospheric restoration but also be accompanied by more complex messages. These messages could concern the potential for human development, cosmic responsibility, and the long-term consequences of technological progress, aspects we often consider within the narrow confines of our existing understanding. If we assume that our ancestors or alien engineers deployed interstellar atmospheric management systems, such systems designed to regulate and maintain planetary environments on scales beyond our current capabilities, then the 3ATS appear to us as both a gift and a challenge. These systems can serve as assistants in restoring and preserving our planets, as well as a reminder that civilizations emerge and vanish over time spans far exceeding human life. One could say that the question is not only about what exactly the 3ATCs are doing in orbit around Mars, but also about what we can learn by observing this remarkable process. It is an appeal to our internal resources of knowledge and reflection on humanity's place in the universe. Moving on to a hypothetical consideration, if there were hypothetically such possibilities that remain unattainable today, a developed civilization facing the imminent threat of destruction would have a unique opportunity to apply quantum archaeology systems for timely forecasting and determining optimal moments for providing assistance in the restoration of Earth or other planets. Imagine underground networks, deep and complex, interacting with planetary systems, could continuously monitor environmental conditions, track the dynamics of technological progress of various civilizations, and timely activate mechanisms for delivering aid at those moments when these civilizations reach a certain maturity and can most effectively use resources to restore atmospheric conditions. In such scenarios, the three crucial atlases governing these processes would not be mere coincidences in time but would represent the result of complex predictive algorithms developed with consideration of numerous variables. These algorithms would determine the precise moment when signals of impending danger coincide with the opportunity for intervention, ensuring timely assistance in the name of saving, for example, the atmosphere of Mars or another planet. Under these conditions, the arrival of a comet could coincide with the detection by humans of certain biosignatures characteristic of Martian conditions, as well as with the development of interplanetary research technologies and an ever-deepening understanding of climate engineering issues. Of course, all this is more a reflection on the edge of fiction, as today we have no real evidence of the existence of such underground supercomputers capable of implementing quantum archaeology or predictive algorithms capable of working with the spatial temporal scales of the entire cosmic era. But this metaphor serves as an important reminder of the direction in which civilization could develop if it possessed the necessary resources and knowledge. It helps us consider how truly advanced technologies and organized systems could approach large-scale problems that cause concern at the level of planets and star systems, rather than just an individual or even a single local culture. Modern computational grids and automated observation tools in the sky largely resemble such fantastic scenarios. Telescopic systems, similar to automatic threat detection systems, work constantly and continuously scan space for potentially dangerous objects. They process vast amounts of data, identify anomalies, analyze patterns, and alert human specialists when something unusual requires special attention. The European Space Agency, along with NASA, uses complex models and forecasting systems that allow for calculating asteroid trajectories, assessing collision risks, and developing plans to deflect potential threats before they approach Earth. The demonstration of successful missions, such as the DART project, has vividly proven that humanity already possesses sufficiently powerful computational and technological capabilities to actively intervene in celestial mechanics, alter the trajectories of dangerous objects, and prevent catastrophes. We have essentially transitioned from the role of passive observers to active participants in the processes occurring in our solar system. However, despite these achievements, our current capabilities are still very limited compared to what civilizations with greater resources, time, and knowledge could achieve. Interstellar atmospheric engineering, for example, would require colossal computational power, the highest precision in forecasts, and technological perfection far surpassing our current achievements. Remember that in the most desolate and vast areas of the world, there are many unique natural materials, such as meteorites, unchanged for millions of years, and artifacts of ancient civilizations. These places hold traces of the past, allowing scientists to preserve and study the history of planets and the development of extraterrestrial life forms with astonishing accuracy. Ancient settlements left by our ancestors and their rich archaeological monuments become unique testimonies of those eras when our home, Earth, underwent its most important stages of evolution. If one considers how someone might conceal an extremely complex computational infrastructure for enormous spans of time, even millions of years, the most suitable locations would likely be the lifeless, barren regions of the planet. Such a place could be an ideal hiding spot for several reasons. Firstly, these areas experience minimal water impact, significantly slowing down processes of decay and decomposition. Secondly, temperatures there usually remain relatively stable over long periods, contributing to the longevity of any structures. And finally, low biological activity and geological isolation create additional barriers against the penetration and degradation of human-made systems by the environment. Thus, underground systems hidden in such areas could, in theory, protect themselves from most external factors capable of causing their destruction or unnoticed interference. Of course, to date, no such hidden technologies or secluded complexes have been discovered, indicating the existence of invisible infrastructures capable of enduring millions of years. Modern science and technology, including the most advanced ground-penetrating radars and various geological studies, allow for the detection and identification of even the slightest signs of large-scale artificial objects, if they truly exist. If such massive structures or shelter systems were present on Earth today, their detection would not go unnoticed, as advanced scientific observation methods today are capable of identifying even very subtle deviations from the natural composition and structure of the Earth's crust. Nevertheless, completely ruling out the possibility of hidden computational networks, designed to operate in secrecy and activated only under certain conditions, would be unjustified. It is quite possible that such systems may be in a state of dormant uselessness and activate only upon receiving specific commands or conditions, thus acquiring a special stealth and long-term invisibility. The metaphor of desert supercomputers allows us to ponder the scale of strategic planning that might be required for the implementation of highly ambitious and seemingly fantastic projects, such as the restoration of a planet's atmosphere. Stories about Mars, which lost its atmosphere over billions of years due to complex and multi-stage interactions such as solar wind, planetary magnetic shield, and atmospheric chemical composition, serve as a good example of potential challenges. To reverse such processes would require a long-term, proactive program of interventions, calculated over time horizons as vast as the atmosphere's loss itself, billions of years. Disparate comets, like Atlas, although incapable of significantly restoring the atmospheric layer on their own, can still play a role as components in much larger and prolonged processes if the delivery of atmospheric substances is carried out regularly over millions of years. Such gradual and systematic contributions could eventually lead to Mars's surface becoming more habitable, without causing rapid and obvious interventions that would attract the attention of any observer, even a highly advanced civilization. The James Webb Space Telescope represents one of the most modern and impressive steps in the evolution of astronomical observation. This instrument allows humanity to conduct deep analyses of the chemical composition of distant cosmic objects, revealing even the subtlest signs of their unusual processes and states. By being able to read the spectral remnants of chemical reactions that occurred millions of years ago, we become witnesses to history, recorded in the molecular signatures of interstellar objects, such as Comet 3ALS. However, despite the incredible capabilities of this telescope, our most advanced instruments may still fail to detect signs of complex atmospheres or engineering structures if such systems were designed to appear completely natural to a civilization possessing our level of technology. Modern chemistry is advancing so rapidly that it is possible to mimic natural processes with incredible precision, making it difficult to distinguish them from natural phenomena. This means that identifying the true sources of such processes would require observational equipment that surpasses our current functionality and sensitivity. Assuming that our hypothetical ancestors, with sufficient knowledge and capabilities, indeed implemented interstellar atmospheric engineering programs, it is quite likely that their actions were driven by experiences gained from a civilizational crisis or collapse. The restoration of the atmosphere on Mars serves as a striking example of such a strategy. It can be perceived as a cosmic insurance, ensuring that even after possible planet-scale catastrophes or other technological failures, habitable worlds remain accessible for the revival and further development of human civilization. This thought raises crucial philosophical and practical questions about our own responsibility as an evolving spacefaring race on the verge of exploring distant planets. Do we need to create long-term plans for the development of technologies and strategies aimed at ensuring survival in the face of potential catastrophes? Should we consider developing projects aimed at restoring the atmospheric layers on Venus, Mars, or even potentially habitable exoplanets that could become the next stage of our expansion into space? Further reflection brings up the question of creating backup systems capable of helping humanity recover from possible emergencies, whether natural, technological, or related to external threats. The mission carried out under the DAR program clearly demonstrated that modern scientists and engineers already have at their disposal the basic tools for implementing celestial engineering technologies. These technologies allow for the detection of potentially hazardous space objects, calculating their trajectories with high precision, and even executing targeted kinetic impact missions aimed at altering the orbital mechanics of dangerous bodies to prevent possible collisions with Earth. Theoretically, these same capabilities could be applied to projects for delivering substances or devices into the atmospheres of planets, although the scale and technical complexity of such operations would significantly exceed current experience. Testing the hypothesis of the existence of hidden technological objects or electronics in deserts involves methods for searching for radio signatures that could indicate the presence of concealed computational networks or hidden technologies in these regions. Unusual electromagnetic anomalies occurring in remote desert areas are also being investigated, as they may indicate the presence of hidden technological structures or chemical signatures generated by advanced technological or scientific processes that we are not yet aware of. However, nothing of this sort has been discovered so far. In the process of searching for hidden archaeological objects, methods continue to evolve. More precise lidar scans, satellite ground-penetrating radar, and increasingly complex geological analyses are being used. These tools offer hope that in the future, it will be possible to discover ruins or traces of artificial structures that previously went unnoticed, even with minimal signs of their existence. Interest in modeling potential scenarios of predictable collapse reflects our inherent desire to understand and prepare for the possible fragility of our own civilization. In light of this, we consider climate change, nuclear conflict threats, risks associated with the development of artificial intelligence, and the risk of asteroid collisions as potential sources of destruction capable of disrupting or completely annihilating human ways of life. Against this backdrop, there arises a quite justified and extremely comforting assumption that somewhere in the depths of space, advanced civilizations exist that have already found ways to solve these problems and have deployed systems to provide assistance and ensure their survival. However, it is important to remember that such ideas about the existence of ready-made solutions and protection systems in other worlds are more philosophical and utopian in nature. As for such systems to work harmoniously, they must operate with high precision, stability, and reliability, which is far from guaranteed. Concepts related to hypothetical quantum archaeology or the concept of desert supercomputers provide interesting metaphors and images for contemplating advanced extraterrestrial civilizations. These ideas help envision what post-catastrophic activity of ultra-modern technologies left by long-vanished civilizations might look like. However, their three unique and unusual signs, combined in the concept of the 3ATS, may indeed indicate the existence of a larger pattern in the structure of our cosmos. However, it is more likely that this pattern is not related to some hidden technology of advanced civilizations, not to secret supercomputers or complex predictive algorithms created by human hands. On the contrary, it may be a manifestation of natural chemical processes inherent in interstellar space, processes that operate independently of our concepts and human technologies. The universe is not obliged to conform to our expectations, nor is it required to provide us with simple or digestible answers to all the questions that arise concerning cosmic phenomena and coincidences. What if the true test for our minds and thinking is not the ability to recognize pre-prepared technologies or predictions, but the ability to maintain scientific curiosity, uphold critical and rigorous analysis when faced with phenomena that significantly challenge our conventional ideas of what is possible and real in the universe? Let us consider this question in more detail as part of the 13th chapter, titled Test. Transcendence versus Ready-Made Solutions. Perhaps the most important aspect raised by the mystery of the three ATCs is not about their essence or nature, but about how we respond to it and how we choose to interpret these phenomena. In this context, the unusual chemical nature and mysterious timing of the supposed comet create a kind of perfect conditions for testing our intellectual maturity and level of scientific preparedness. We are faced with a choice. Do we seek cozy, convenient explanations that require little effort, or are we ready to take the difficult path, the path of deep scientific investigation, gathering compelling evidence, and truly understanding what is happening? It is important to understand that the structure of this test does not necessarily have to take literal forms or manifest as a specially prepared exam. The phenomenon of the three ATCs itself seems to have arisen in nature not by chance and not with the purpose of putting us all through a formal test. However, the universe regularly presents us with phenomena that challenge our assumptions, prompt a re-evaluation of established hypotheses, reveal our biased views, and force us to choose, either to take the risk by delving into scientific research or to succumb to illusions and self-deception. It is how we respond to such unexpected challenges that defines our path in science and the civilization we are a part of. Reflecting on the real conditional exam questions posed by the mystery of the three ATCs, several specific examples can be given. Will scientists be able to maintain funding and interest in returning samples from Mars despite growing political pressures, economic constraints, and public distrust? Will we manage to keep astronomical observatory networks open and transparent despite their exorbitant costs and the need for constant technical arsenal updates? And finally, will scientific institutions be able to resist the temptation to sensationalize and exaggerate the mysteries of space to attract mass interest and attention on social media? All these questions are not just theoretical reflections but living, practical dilemmas that directly determine our ability to make fact-based decisions in conditions of uncertainty and pressure from public opinion. Such a situation particularly illustrates the importance of testing the transcendental boundaries and making complex decisions. The success of a mission like DART, related to asteroid deflection, is a vivid example of how science can provide a practical and convincing solution based on thorough analysis and technological capabilities. When humanity first applied the technology to alter the trajectory of the Dimorphos asteroid, it became a clear demonstration that scientific knowledge and methods, grounded in the collection of objective data, can serve as a reliable foundation for confronting real cosmic threats. Unlike speculative and often unsubstantiated conjectures about extraterrestrial artifacts, in the modern information space, social networks often act as platforms where extraordinary statements and sensational claims dominate, frequently based on subjective impressions or unverified data. In this context, the algorithms governing these platforms amplify the spread of such hypotheses, often adhering to the laws of popularity and rapid audience attention. In contrast to these trends, scientific institutions and research centers strive to maintain attention based on balanced, convincing analysis grounded in facts and evidence. As a result, the signal-to-noise ratio in the information environment deteriorates because speculation spread faster than verification and validation can be conducted. In situations where there is a need to respond to hypotheses about potential anomalies or mysterious phenomena, it is important to remember NASA's example. The organization's response to claims of discovering mysterious artifacts illustrates how modern science should address public speculations related to unusual anomalies. Instead of either immediately dismissing possible concerns or engaging in complex refutation procedures, the space agency prefers to provide the most transparent and accurate information possible. It clearly explains what exactly was recorded, what level of uncertainty is present, and what conclusions are based on the available data. Meanwhile, the truth remains in focus. The agency acknowledges existing boundaries and unknowns while maintaining strict scientific standards regarding the stated extraordinary claims. Short-term forecasts based on analytics models within the 3IATLS system serve as a valuable tool for testing hypotheses and models refined for assessing the behavior of cosmic objects, such as comets. These forecasts allow for the observation of changes in the ratios of components, such as carbon dioxide, water, and organic cyanide forms, as solar energy penetrates the comet's core during its approach to perihelion, the closest point of its orbit to the Sun. Upon reaching this point, it is expected that observations will reveal characteristic changes and weakening of certain patterns that correspond to the physical laws governing natural comets. In such scenarios, if the 3IATLS system were artificially controlled rather than subject to natural laws, signs indicating human intervention could be detected regardless of initial assumptions. For instance, constant acceleration outside gravitational influence, unusual radio signals, chemical emission patterns not matching stationarity or distance from the Sun. All these could indicate the presence of an artificial control system created by intelligent systems. However, the absence of such signs does not automatically confirm the comet's artificial origin. The development of technologies and systems for controlling space objects is complex enough to mimic natural behavior without signs of intervention. Therefore, the main principle remains: extraordinary claims require extraordinary evidence. Without clear and obvious violations of the fundamental laws of nature and physics, the scientific community by default adheres to the assumption that the observed substance, such as 3IATLS, represents something unusual yet entirely natural and following the logic of nature, something that operates according to predictable physical principles. The global network of astronomical observatories that tracks objects similar to the 3IATLS system is one of humanity's greatest achievements in international scientific cooperation and advanced technology. The collaboration of leading astronomers from around the world, the use of space telescopes, ATL systems, P-stars, and observation platforms of the European Space Agency allows for continuous monitoring of near-Earth space and the detection of even the faintest signals and unusual phenomena with unprecedented accuracy and scope. This opens up unique opportunities for identifying and verifying any actions that may indicate unusual space behavior. Such transparency and information presentation creates favorable conditions for broad public involvement in the scientific research process, while simultaneously promoting the maintenance of strict professional standards of data analysis and interpretation. Maintaining an open dialogue with citizens regarding events related to the Third Astronomical Telescope structure represents an important educational platform. Public involvement ensures not only the fulfillment of the informational mission but also contributes to the development of skills to distinguish reliable, peer-reviewed scientific conclusions from speculative interpretations, which are often based on unverified versions or emotional conjectures. Thanks to such involvement, citizens can better understand the mechanism of scientific consensus formation, specifically how accumulated facts, verified research, and critical analysis combine into robust theories and models. Upcoming key events related to the study of the object designated as the third telescopic structure gain particular significance in the context of such informational openness. In particular, the passage past Mars, scheduled for October 3, and the perihelion passage, occurring from the 29th to the 15th of October, serve as concrete starting points for analyzing the behavior and characteristics of this interstellar structure. These dates provide a unique opportunity for conducting natural experiments that can confirm or refute existing scientific models regarding the chemical composition of interstellar comets and the peculiarities of their orbital paths. In this context, the choice of direction for further research, whether focusing on transcendent attempts to understand the nature of these phenomena or on utilizing existing, ready-to-use hypotheses and explanations, directly influences the methods of interpreting upcoming observations and obtained data. On one hand, the transcendent approach requires scientists and researchers to deeply delve into the complex fields of interstellar body chemistry, orbital mechanics, and the specifics of remote analysis methods. It implies developing tolerance for uncertainty, as understanding such complex processes is often a trajectory of trial and error, constant reevaluation of hypotheses, and openness to new, sometimes unexpected solutions that can challenge existing theories. Although this path demands significant intellectual and time investments, it allows for the construction of more fundamental knowledge that can become the basis for further groundbreaking discoveries. In contrast, the approach based on ready-made solutions immediately offers quick and often simplified explanations of observed phenomena. Within this method, the theory of alien artifacts becomes appealing, as it does not require deep immersion into the complexity of scientific details. Spectroscopic data, hyperbolic orbits, or remote chemical analyses are perceived as sufficient grounds for obtaining immediate answers. This approach creates a sense of intellectual convenience and allows for the avoidance of long and difficult scientific processes because all answers are immediately presented in the form of simple, understandable hypotheses, eliminating the need for serious preparation and understanding of analytical subtleties. However, these two choices, deep science and quick assumption, have not only scientific but also moral dimensions, extending beyond purely technical aspects. Here it is important to ask ourselves, how does human civilization respond to the mysteries of the cosmos? Are we capable of developing the intellectual tools that will allow us to recognize extraordinary, truly unusual phenomena, and how suitable is our current infrastructure for this type of research? Is it important for us to maintain a scientifically grounded approach, or are we inclined to create an information environment that encourages sensational hypotheses and superficial analysis, which often hinders the honest distinction between genuine scientific mysteries and artificially created controversies designed to attract attention? The stakes in this matter undoubtedly go beyond just one pseudo-scientific discussion. As human activity in space expands, we will inevitably encounter phenomena that may challenge our existing knowledge of physics, chemistry, and biological processes. The answer to how we will react to phenomena similar to the third astronomical telescopic structure is crucial. Some mysteries hidden among the vast expanses of space may remain inaccessible to our current level of technology and observational capabilities. Solving such mysteries requires not only modern equipment but also a particular intellectual honesty and a rigorous methodology capable of resisting the temptations of simplified interpretation or hasty conclusions. In this context, the term transcendence suggests an internal choice, an aspiration towards curiosity and exploration rather than certainty and dogma, towards evidence rather than speculation, and towards collaborative efforts among scientists united by common goals and interests, instead of working in isolation from colleagues. Such efforts include funding powerful telescopes and orbital stations, training and educating researchers, and fostering international cooperation, without which true progress in science would be impossible. Any attempt to find definitive, exhaustive solutions, whether it be the discovery of alien artifacts, assumptions about ancient interstellar civilizations, or conspiracy theories related to governments, are all superficial explanations. They require less effort, do not demand learning and personal growth. But the universe seems designed to reward the curious, those who do not stop, who explore with insight, and who patiently and meticulously seek answers. In this context, the IATL experiment becomes an opportunity to demonstrate that humanity is ready to face a real challenge: the mysteries hidden among the stars. The choice is ours. What paths we will choose, what kind of human model we will become. Nevertheless, the consequences of such decisions could extend far beyond our current understanding of interstellar chemistry, the atmospheres of other planets, and the potential for colonizing Mars. We can either adapt to new challenges or remain confined within familiar stereotypes. However, as we venture into space, we encounter phenomena that sometimes surprise even the most seasoned scientists, for space continually presents us with stranger and more astonishing mysteries than we could have imagined. Part 14. Choice on Mars. A point where everything can take a new turn. October 3, 2025, is not just another date in the astronomical calendar. On this day, the Atlas Trio, a cosmic object classified as a long-period comet, will make its closest pass by the planet Mars in recorded history, approximately 30 million kilometers away. This flyby, despite its peculiarity, is close enough for the gravitational field of the red planet to exert a modest influence on the comet's trajectory. At the same time, it will be distant enough to rule out any dangers of collision or other dramatic interactions. During the few critical hours of this astronomical event, the cosmic object from distant stellar realms will occupy the same region of space that Mars did billions of years ago, a planet that may once have had water and possibly the conditions necessary for the emergence of life. At this moment, two important lines of cosmic history will intersect. The first is the history of our planet and its ancient times when water existed here and the first forms of life might have emerged. The second is the modern history of interstellar chemical processes, where processes may be occurring in the vicinity of another world that we cannot yet fully understand or imagine. The hope of obtaining detailed data during such an encounter rests on the equipment installed on the European Space Agency's orbital stations, Mars Express, and Trace Gas Orbiter. These spacecraft are our best hope to capture and understand the occurring phenomena. They are equipped with instruments specifically designed to analyze the chemical composition of Mars' atmosphere, detect trace gases, and capture images of small objects near the planetary surface. If around October 30th, the comet exhibits any unusual behavior, these orbital apparatuses will be able to quickly detect the emissions from the core of the cosmic object, carbon dioxide and water vapor, are expected to form a noticeable comet, which, as it approaches the Sun, develops predictably, reflecting the characteristic features of the process. This unfolding of phenomena is related to the fact that as solar heating increases, gases begin to be released intensively from the core, creating a bright tail glow and forming a characteristic atmosphere around the comet. Depending on the distance to the star, this development follows an established pattern. As it approaches closely, the brightness intensifies, and the comet's activity reaches its peak. Any deviation from this expected behavior could signal that the comet is being influenced externally or that its composition is extraordinarily complex. Particularly noteworthy in this context is the mention of the green glow that was observed in September of last year. If we assume that this green hue intensifies as the comet approaches Mars, it would provide scientists with an opportunity to more accurately determine the molecular mechanism responsible for the coloration. Among the candidates are cyanide compounds, dicarboxylic acid molecules, or other trace chemical compounds present in the nucleus. The closer the solar radiation penetrates into the comet, the more noticeable these chemical signatures will become, allowing valuable insights into the chemical composition and formation process of the interstellar materials from which it originated. However, it is at this stage that two sharply divergent theories begin to emerge. The first suggests that the comet is evolving naturally, according to the laws of orbital mechanics. In this scenario, the three ATCs will follow a strictly predictable hyperbolic trajectory, determined by gravitational forces, solar heating, and the typical sublimation process characteristic of comets. This approach excludes any idea of conscious control or intentional delivery of substances into the planet's atmosphere. The gases and dust released during this movement will exhibit signs of standard physical and chemical reactions consistent with known models of cosmic objects. The second hypothesis goes far beyond classical science and suggests that the comet's behavior may be controlled or artificially directed. In this version, it is believed that the three ATCs will exhibit characteristic signs of deliberate emissions, concentrated single emissions of carbon dioxide that may tend to be directed towards Mars, or demonstrate anomalous chemical reactions unattainable by natural processes, all indicating something more complex than a mere natural phenomenon. It is possible that, as a side effect, there is nothing less than the intentional release of substances, indicating the presence of mechanisms controlled by a civilization or another form of intelligence. The overall illusion that the comet is a typical natural phenomenon only makes sense when its behavior perfectly aligns with predictions based on the laws of physics and orbital mechanics. However, if observations show deviations, such as unexpected concentrations of chemical substances, anomalous emission directions, or unusual brightness of the tail, it may suggest the possibility of artificial interference or targeted control. In the classical scenario, the three ATCs move along a predictable hyperbolic trajectory, leading to solar heating and sublimation of ice and gas under the influence of sunlight, without any signs of hidden mechanisms or intelligent interventions. Modern chemical analyses allow us to compare the ratio of carbon dioxide to water, which in this situation is 8:1, a metaphor for how we perceive and process ambiguous information. Such a ratio resembles the thickened atmosphere created by carbon dioxide, prompting us to ponder the transparency of our knowledge. Do we maintain clarity, like the thin Martian atmosphere that allows unobstructed observation of phenomena, or do our conjectures form dense clouds that hinder true understanding? Recent calculations show that the laws of nature and physics, embedded in the foundation of all existence, continue to function and operate regardless of whether we can observe them directly or not. For example, solar heating will continue to affect an object, causing the sublimation of volatile substances from its core, just as it happens with the three atlases. At the same time, gravitational mechanisms remain an integral part of controlling its movement, determining its trajectory and nature of motion. All unusual phenomena and behavior of the object during invisible periods should, in theory, leave noticeable traces, in the form of changes in chemical composition, structure, or appearance, which can be identified once observations become possible again. These traces, recorded after the invisible phases, allow scientists to draw conclusions about the processes that occurred inside or around the object during its invisibility. The European Space Agency, demonstrating a rare transparency for such organizations, openly discusses the potential challenges and prospects associated with studying these enigmatic bodies and directing our observations towards Mars. Unlike previous interstellar visitors that penetrated the solar system with minimal approach radii to major planets, the three atlases present a unique opportunity to gain valuable information. They offer a chance for comparative analysis of interstellar chemistry near a potentially habitable world, which was previously difficult to achieve. Observations of them, scheduled to begin in late November, right after the expected perihelion, will allow us to determine how exactly solar heat has affected the chemical composition and appearance of these objects. It is quite natural for comets, as they approach the Sun, to exhibit increased activity, as their surface and inner layers become warmer, causing volatile substances to evaporate and visually enhance the object's activity. Gradually, as they move away from the Sun, these substances deplete, and comets enter a state of dormancy, becoming less bright and active externally. However, any deviation from this standard picture, such as an unusually rich core composition or signs of artificial intervention, will become an important signal, opening new horizons for research and understanding. The current Mars sample return mission, despite recent delays, remains our most powerful tool for direct analysis. It offers the chance to find biosignatures, that is, signs of possible ancient life, in Jezero Crater or other locations of particular astrobiological interest. The samples obtained could provide the definitive argument regarding the existence of past life on Mars, as well as its possible disappearance due to catastrophic climate changes or other factors. The importance of this mission is further heightened by the emergence of three interstellar atlases, which, like visitors from distant star systems, might have brought with them chemistries previously beyond our reach. These chemical compounds and materials serve not only as a curiosity for scientists but also as part of a broader and more significant narrative about the potential habitability of other planets, their evolution, atmospheric changes, and the possibilities of life recovery on worlds that have experienced climate catastrophes. However, it is crucial to exercise caution and not rush to conclusions by linking incidental findings or observations. The discovery of ancient biosignatures and the presence of chemical substances in interstellar objects characteristic of atmospheres or bioreconnaissance do not necessarily mean that these phenomena are directly related or indicative of life. All this could simply be coincidence, random events that hold significance for those who observe them, namely, humans, but do not necessarily reflect the objective reality of cosmic processes. The universe, in its infinite diversity and complexity, is not obliged to conform to our expectations or tell us a simple and comprehensible story. On the contrary, it often presents unexpected and complex phenomena that challenge our assumptions and theories. The analysis and interpretation of data on Mars and interstellar objects open up before humanity. We must take into account the inherent uncertainty, while respecting and adhering to the strict standards set for the most significant and exceptional claims. Our aim is to avoid hasty conclusions driven by the pressure to provide immediate explanations that satisfy instant curiosity but often hinder a truly deep understanding of the situation or the nature of the observed phenomena. If we choose the path of speculation and assumptions without sufficient grounds, we risk imposing our own narratives based on imperfect data, emphasizing only coincidences or improbabilities, and allowing dreams to fill the role of rigorous scientific analysis. We can easily become captivated by the search for patterns, following intuition or assumptions, even if these patterns do not actually correspond to the real state of affairs in the sought-after data. There comes a point when our internal experience and perception become more important than technical details and data. The main challenge is not so much specific parameters, such as the 3ATS, but ourselves, our internal state, our readiness to face extraordinary phenomena without losing our spiritual and intellectual balance. Are we ready to consider true anomalies and unusual phenomena without succumbing to panic or rash reactions? Can we maintain our scientific curiosity and critical spirit despite the pressure of expectations or the desire for simple answers? These questions resonate particularly sharply, as the red planet, like an eternal guardian, awaits clear and honest answers from humanity to these invisible challenges, for billions of years. That is its mission and expectation. In a few weeks, when an interstellar visitor passes by Mars and Earth is distracted and turns its gaze elsewhere, the consequences of our decisions and approaches will become apparent. Then we will learn what kind of cosmic citizens, what kind of collective intelligence we have become in the process of this encounter with the unknown. An important decision made on or related to Mars will be of great significance for any future contacts with the mysteries of the universe that challenge our established notions of what is possible. At this moment, we are not just observing the 3ATS or analyzing current data. We are laying the foundation for humanity's response to all cosmic anomalies yet to be discovered and understood. It is this choice, to follow the path of transcendence or to maintain our safety, that will be defining for the future. In the shadow of Mars, in those moments and situations when we encounter mysteries from the depths of distant star systems, from the bowels of another planet, as if from the distant past of another star, something seems to exhale snow made of carbon in the vacuum of interstellar space. This substance carries a complex chemistry that we are only beginning to decipher, studying its molecular codings and languages. The damn hypnotic rhythm of cosmic coincidence has brought us to this current moment, when we stand on the brink of new discoveries and possible insights. At the same time, an interstellar object, loaded with chemicals for atmospheric restoration, moves toward our plans. It seems to hit a point of synchronicity as we begin to uncover extremely compelling evidence of ancient life on the red planet, of traces that remain crucial clues for us. What we know more or less accurately can be stated clearly and without unnecessary embellishments. It is known that the 3ATS originated outside our solar system, as confirmed by its hyperbolic trajectory and speed, exceeding any internal routing, which will forever carry it back into interstellar space. Its chemical composition exhibits unusual features. For example, the ratio of carbon dioxide to water is approximately 8:1, one of the highest recorded in the history of studying such objects. When this interstellar object, tentatively named Atlas, approaches Mars at a safe distance, discussions about the existence of extraterrestrial artifacts, hypotheses about the activation scenarios of human DNA, and cycles ranging from 30 to 600 years remain purely hypothetical theorems, confirmed only by rare coincidences and subjective observations. Such ideas possess a certain psychological allure and serve as a convenient tool for crafting engaging narratives. However, they are mostly based on coincidental facts or random occurrences that may seem significant only due to our natural inclination to seek patterns. Nevertheless, the accumulating examples of coincidences and similar elements raise increasingly pressing questions among scientists and skeptical researchers, as they challenge the purely scientific approach to data analysis. Here is an example. The time required for interstellar chemicals to reach Mars sometimes coincides with periods when scientists discover potential biosignatures, signs of possible life or its traces, in the Jezero Crater. These facts are often perceived as indications confirming the existence of mysterious connections between cosmic chemistry and the development of life on the planet. At the same time, chemical compounds perfectly capable of restoring the planet's atmosphere appear precisely when humanity shows heightened interest in exploring celestial bodies and developing interplanetary flight technologies. This creates a sense of patterns that may have significant scientific implications or may simply be the result of our tendency to find patterns where none exist. Sometimes such sequences or coincidences occur precisely because our minds have evolved to recognize structures and connections in chaotic or complex systems. We tend to attribute special significance to random events, interpreting them as symbols or signs of something greater, which is essentially just the result of our need to find meaning in the surrounding world. Phenomena regularly arise in the universe that seem meticulously designed and orderly, but often this is an illusion caused by ignorance of the natural causes of these processes. Until we unravel the mechanisms behind the emergence of certain cosmic signals or unusual events, we will perceive them as signs, as evidence of hidden wisdom or intentional planning. At the crossroads of these assumptions and facts lies an important dilemma. On one hand, the pursuit of thorough study based on empirical data and scientific methodology. On the other, the tendency toward hasty conclusions that may provide temporary confidence but obscure the true essence and prospects for further discoveries. Reliable knowledge requires not only patience and persistent research, but also intellectual courage, the willingness to fund space programs, support international cooperation, and develop advanced technologies. Such efforts involve significant investments in telescopes, scientific institutes, and interstate initiatives, as only through joint efforts can we come closer to unraveling the mysteries of the cosmos. Patience is necessary in awaiting answers, as nature is often hidden behind layers of complexity and uncertainty. Openness to new possibilities and readiness to embrace a shower of fundamental scientific discoveries are what keep us on the right path. This means we must systematically and diligently study spectroscopic data, satellite orbit mechanisms, and the chemical composition of planetary atmospheres. Only in this way can we avoid the trap of easy explanations that require minimal effort, explanations based on hypotheses not supported by science or backed only by superficial reasoning. The transcendent path to truth leads through renewal, and Europe can play an important role in this field. In this regard, international research, observational programs, bulletins published by NASA, and peer-reviewed articles documenting the evolution of the so-called three atlases, hypothetical interplanetary objects or signals that may hold the keys, gain special significance. They require nothing from us but faith, neither new knowledge nor financial investment in costly research, nor complex and tangled partnerships. All they need is trust, an inner sense that we can stand by our views, that we can deal with phenomena that raise questions and challenge our understanding of the boundaries of human comprehension. After all, the universe seems specially designed to reward curiosity, to offer discoveries, to lead research, to demand patience and inquisitiveness, helping us develop insight and analytical skills. It rewards those who do not rest on their laurels, who can discover something new, unravel complex patterns, and draw attention to them. The three atlases are not just a set of data or a project. They are a testament to humanity's growing ability to observe and understand interstellar phenomena with each new discovery. Every aspect of its chemistry, every calculation of the trajectory of an unknown particle or object, every observation of the behavior of cosmic formations adds to our collective knowledge. These observations help us understand how the laws of chemistry and physics operate on a universal scale, how planets, stars, and interstellar objects interact. These are genuine steps in space exploration that bring us closer to unraveling the secrets hidden in the depths of cosmic space. Perhaps the true revelation does not come directly from the third atlas itself, but is embodied in the accumulation and analysis of the knowledge it allows us to gather. It is through the meticulous study and processing of this data that we begin to understand how interstellar matter interacts and how objects in neighboring galaxies and star systems behave in reality. something far greater than just a beautiful picture on a screen. The more we refine our detection networks and the more interstellar visitors, the so-called interstellar objects, we manage to identify, the more we can discern patterns and develop more accurate models to understand the chemistry, frequency, and behavior of such bodies. This is a continuously expanding field of knowledge into which we are investing our efforts. The Mars Sample Return mission plays a special role in uncovering the secrets of the planet. Whenever it happens, in the coming years or slightly later, the results of this endeavor could provide definitive answers to questions about possible ancient Martian life. These findings could fundamentally change our perspective on the origin of life in the cosmos and how Mars might once have become a habitable environment. If the leopard spot-like textures found in Martian clay sandstones turn out to be genuine biosignatures, then the story of atmospheric chemistry delivery and its impact on the planet's development will become part of a broader narrative about planetary habitability and the process of biological system recovery. Even if ancient life on Mars is confirmed and similar chemical processes are found in interstellar objects, we must be cautious and avoid hasty and one-sided conclusions. Our interpretations should not turn into obsessive teleological explanations, that is, assumptions about the purposeful nature of cosmic processes, without sufficient evidence. It is entirely possible that the universe, even if rich in habitable possibilities, is not specifically designed for life as we can recognize and understand, and its structure may have a much more complex and ambiguous nature than it appears to us. The choice between exploration and mere comfortable speculation is not purely a philosophical question. It has practical implications for the further development of human civilization. In how we proceed lies our ability to create the intellectual and technological foundation that will allow us to recognize the most unusual and strange phenomena encountered in the universe. If we choose to carefully analyze and approach new phenomena with disciplined uncertainty, we can build reliable systems for recognizing truly unique cosmic phenomena. The data we collect and analyze will either confirm our hypothesis about the nature of so-called natural comets or reveal unexpected anomalies that could seriously challenge existing theories and models in the study of cosmic objects. If our assumptions are confirmed, we will be able to take an important step forward, expanding existing knowledge and strengthening the scientific foundation on which modern concepts of comets and their origins are based. However, if the natural features of these bodies turn out to be more complex, unusual, or mysterious, it will signal the need to revise our understanding and develop new, deeper, and more accurate theories. Any of these scenarios, regardless of the outcome, represents a true achievement for science and for the approach to understanding the universe, which can be called transcendent because it helps to go beyond everything previously known, expands the boundaries of human knowledge, and helps us better understand the surrounding cosmos, its mysteries, and laws. Such an approach, based on openness to new facts and the pursuit of true understanding, will ultimately be successful only if reality indeed aligns with our initial views and expectations, which we form based on available data and theoretical premises. However, the universe does not always adhere to such calm scenarios, and it does not guarantee that our assumptions will be accurate or that it will conform to our preferences. On the contrary, what the Tritium satellite is doing in Mars orbit and the phenomena observed there remind us that nature follows its own laws. This nature manifests in gravitational mechanics, which governs the motion of celestial bodies, and processes that sublimate volatile substances under solar heating, creating chemical reactions and compounds characteristic of the formation and evolution of objects around distant star systems. All this reminds us that the cosmos obeys the same laws as all other natural phenomena. Nevertheless, there are concerns that sometimes we may become too engrossed in our interpretations and patterns, which seem to reflect our hopes and fears more than the actual structure and course of events occurring in the vast cosmos. In other words, we may see not so much the objective truth as our own expectations and projections, which often prevent us from seeing the true picture. However, the choice we make, to look at the cosmos from the perspective of science and the search for genuine anomalies, or to seek confirmation of our already formed views, is determined not by the cosmos itself, but by our internal beliefs and values. It is up to us whether we will be capable of developing a transcendent path of curiosity based on evidence and objective facts, or if we will choose a safer strategy, where we take refuge in explanations that require no effort and trust beyond faith in our own prejudices. We face an important decision: will we create tools and methods that allow us to recognize true cosmic anomalies and unusual phenomena, or will we limit ourselves to seeking patterns that confirm existing dogmas and knowledge, keeping us within the confines of familiar concepts? This choice holds the key to understanding. Its correctness determines the contribution we will make to the knowledge of the universe. In the shadow of Mars, in the cosmic expanse, an interstellar visitor continues its ancient and endless journey, carrying with it chemical compounds and compositions whose origins trace back to distant stellar neighborhoods that we may never reach or even comprehend. These cosmic chemical compounds may seem like random coincidences, manifestations of a cosmic plan, or something entirely beyond our current categories and ways of thinking. Each of these hypotheses requires time, attention, and effort to test and understand. The universe patiently awaits humanity's further development and refinement of its tools and theories to comprehend these phenomena in their entirety. We must not forget that our understanding is still very limited, and with each new